seeing the audience, I am not considering this house. In this house, as a vice chancellor, I am a researcher and a teacher. So, in that constraint, I will like to put the questions and answer very lively and constantly. So, my job also made easy with two earlier speakers, the government notions and their approaches and their different type of application that the Maharashtra government has already taken over. We are working in earlier university with my research team on this domain around in AI and machine learning. My area of research is machine learning and artificial intelligence, and that of advanced level of technology, where we have taken this agriculture application as a priority consideration. So, images, data, and different type of applications are to be there for agriculture application. What geospatial technology means, in a nutshell, I will put in front of you a brief about the precision agriculture, then how the precision agriculture is supporting helpful for development applications for in our technological constraint. So this is not my domain, but being a farmer son, I am very much deeply attached with the agriculture sector. And precision, it is by definition a farming management concept that uses technology to observe, measures, respond, to feel the variability of the various approaches and mechanism to take it ahead for more productivity. And what we need to precision and precision and accuracy is always required, but what type of, how many number of doses of the fertilizer and pesticides required for a particular crop, that has been accurately with the technological concept. So, silent picture about this site-specific crop management, which has already taken the biggest level of project, data-driven decision making, integration of the geospatial and the digitization, and some of the outcomes that we have expected, everyone is expected. Higher yield and efficiency, reduce cost and waste, and sustainable resource of the users. So, taking to ahead what the geospatial technology and how it will be helpful for the sustainability farming. So, before that, geospatial technology, I would like to put in front of you all. Geo means geographical, and spatial means three-dimensional formation. So, what are the things are laid out on the surface, on the ground, and that particular surface covers a different type of crop, different type of forest, different type of minerals, different type of soils that has to be mapped without touching to that particular composition. So in geospatial property, remote sensing or airborne satellite data, these are the one component as a consideration of the data, whereas measures, various measures and sensors also considering critical part. For geotagging also, location also, tagging also, and references also. And apart from the imaging sensors and airborne, there are various mechanisms for measuring the difference, like precipitation measures, humidity measures, temperature measures. These are also sensors, and these particular locations have some dual time. Altogether, there are different combinations of the geospatial aspect and the sensors put together to forwardly handle the application of the geospatial technology. So, what are the base approaches for geospatial technology for sustainable farming, which has been already elaborated well? What particular crop required? What disease that it suffers? How long it is going to produce? Yield estimation, area mapping, mixing particular pixels. These are the challenges. Government required digital plot. How many losses are there? Cannot able to measure it directly. So, with the help of the data, we can be able to measure easily. And there is a question as the natural system or artificial system, how we can differentiate the bajra and jowar in between. At the condition level, differentiate, but at the small sort level, we cannot able to differentiate. So, the satellite data having the major challenge, how to differentiate the plant, or how to differentiate the species, or how to differentiate the crop at the pre-mature level or the 1 month or 2 month level, to take the area estimation and to take the overall mapping for decision making to the government or to the regulatory authority side. So, digital image, binary image, monotone image, beyond that, there is an image which is supposed to be taken from the hypervector, which are having the multiple layer of the data, which gives the more detail. So, as a farmer, I can understand easily after 1 month which is the jawar crop and which is the bajra crop, because the canopy of the crops and leaves are some to be similar. But the machine cannot able to understand. So approach for the geospatial technology is that you take the consideration of the reflectance from the surface of the plant canopy, and then you can map its characterization. So likewise you can map what are the generals, what are the deficiencies occurs in the particular crop, and so that we can use the fertilizer altogether. So remote sensing and GIS and IoT and sensor, AI and machine learning, these are the technology and sensors how to collect the data. In earlier session in Maharashtra, even though the digital image, RGB image are supposed to be used, but that digital image having a lot of limitation, we cannot elaborate the fine detail about the crops and the differentiation in between as in the picture. And that's why we require the hyperspectral data. So in geospatial data, we use hyperspectral in our university laboratory, that is in the Symposium itself. And we do have some Kharif and Rabi characterization to identify the spectral signature. So machine can understand what is bajra, what is jawar, what is moong, what is udid, what is tur. So different crop artificial is essential for the artificial machine to recognize that particular crop, and then we can map the average hectare area of the crops. So I will skip this particular technical part much more detail because it's required a different type of sense of understanding. It is just general history up to 2010. But 2025, the new dimension of the technology comes into the picture to handle this agricultural data, that in terms of hyperspectral data, and that data is also having limitation with the digitization, and that's why now in the current scenario, quantum technology comes into the picture. I will put some little slide altogether. So data aggregation, data characterization, data analysis, classification, its interpretation, and then we can identify its yield estimation, productivity, area mapping. These are the various challenges faced by the farmer, even though the NGOs and government. And with this technology very easily to track it out. Already we have done some experiment at the end I will show you. So this is again not important for all of us. Which particular sensors are required to characterize the crop patterns that are the sensors available in the market, and with the help of those sensors we can collect the data in non-imaging form. So here the data is in imaging form, that is in the green form, and in the non-imaging form. For calculation of the hyperspectral spectral signature, we require both. Even though we require ground truth, and in morning session there is some discussion about the ground truth. So ground truth gives you the location, ground truth gives you the area, ground truth gives you the specific signature of the particular pattern of the crop, and then you can map it on the overall satellite complete area to layer it, and then we can able to understand. Simple combination of the remote sensing might be someone already known to it. I will just skip it. Can able to take it up to some particular limit, then we require the flying irrigations and aviations and all. So drone technology playing an important role again for the collection of the data at the local remote level, and from that we can able to make the model, and with the help of that model we can achieve the desired level of consideration. So these are various platforms we are adapted by the different countries in the world. What particular consideration you need to supposed to be considered together. And this is what one picture, that is these remotely sensed data that we can gather in Setu and off the Setu. That means touching to the near to the plant with the sensor and some space, altitude level. So if the need to be for some hectares or acres to be scanned, we use the simple drone or airborne, and then the last is the satellite data, which is very high altitude altogether to cover the entire state or entire country region. And two type of sensor, active sensor and passive sensor, even though night, even though the thunder, we can able to collect the data with the help of this technology. So electromagnetic spectrum spilling here, and where the infrared, microwave meter rate to the visible range spectrum, these are the zones for the hyperspectral imaging sensor, and this sensor playing an important role to capture the data either in the multispectral data or in the hyperspectral data. Frame by frame, pixel by, this is again technological constraint, how you can elaborate the data and how you can read the data with, on the characterization. So what the image sector that we required specifically, if the data collected is good on the basis of 4 resolution, spatial resolution, spectral resolution, radiometric resolution and temporal resolution. If I need to scan a particular development of the crop just from going to the cultivation level, I have to continuously monitor with the help of geosatellite mechanism. So what is the crop condition at first month, second month, third month, fourth month, and the cultivation level. I need to have the satellite geostationary position at some altitude level and continuously scanning. Spectral resolution means its reflectance characteristics, whether it is a thunders or a good light or bad light, even though I can able to collect the signature from the surface. Radiometric resolutions and temporal resolution, again this is time based, and where we are going to supposed to store. If my storage mechanism digitally is required 16-bit and my sensor is 8-bit, then there is a degradation at the level of sequence. These are the technology terms in terms of advanced level of image processing for data calibration and data authentication. This is the important for me and you all. So what we do to recognize me, I know the Professor Mani because we had seen him, I listen him, I observe his face, I observe some specific character. The moment I observe, my neural network get activate and I can say, yes, this is the Professor Mani. So same thing that we can achieve through the artificial intelligence, and there we require some neural network pattern recognition mechanism. And for that, we need to design a signature, and that signature is a spectral signature. So my photograph, my scene, my face, my hairstyle, my goggle, external behavior characteristics observed by the sensor, and some internal behavior characteristics collected together, this is my signature. So to recognize an object, artificial intelligence required to recognize an object with the help of signature. And within that signature, behavioral canopy signature, spectral signature playing an important role. So what spectral signature? Within the frame of the room temperature or within the frame of some particular what particular reflectance, this side you can see that this is the reflectance and this is the wavelength, that is in nanometer. And you can see that generally surface level observation get mapped in the common signature. If you assume for time being on the earth there are so many animals, apart from that animal, human being is one animal, and if there are cows, there are buffaloes, there is a dog, there is a human being, and if you ask that who are they, we can easily see differentiate altogether. Why? Because of the common signature is adapted by our human brain pattern, and we can memorially identify those particular things on the basis of that character or signature. So same thing that we need in artificial intelligence. What is jowar, what is bajra, what is cotton, what is maize, what is sugar cane. Accordingly, we need to set the pattern of the signature of the particular crop. Once you know the signature of the crop, then that signature has supposed to be get captured with the help of sensor, and then that sensor has taking the mapping area consideration altogether. But this is not so simple job. When my flight is flowing at 110 kilometer away from the surface level, we can observe that all are green, all are vegetized. And within that vegetation, I cannot able to differentiate with the help of some simple picture, which is bajra, which is jowar, which is sugar cane. And that's why that comes in the high level of image processing, and that high level of image processing even though requires some level of deep bit of the pixel data. And generally, we can classify. If you take the photograph of Parbhani district from a satellite or from a aircraft, and we can see it in as a scene classification, we can see that there are some mountain area, there are some plain land area, there are some green area. This is the scene-based classification. And on the basis of scene-based classification, we can see that if we have the toposit data on the surface level, we can easily map on the basis of scale level, and we can see that in Parbhani district, cotton agriculture sectors crop is so many hectares because of the general classification. But there are so many other mixing pixels also, and that's why this is the worldwide signature. This is a common pattern has been generated by the worldwide scientists. If there is a man, general signature. If there is a buffalo, general signature. Maybe there are not a same buffalo are similar to same. Not a single persons are again similar to same in the world. I have my own identity, you have your own identity, and that is the God-gift nature. So every aspect or every live things, or whether it is small or big, having its own characteristics. Professor Kale is only Professor Kale. There might be similar to me, but it is not Professor Kale, and that is what the unique identity. Likewise, every species, every object having its own identity, and that is what we call as the signature. So likewise, worldwide, we can see that if you observe the sensory mechanism through the sensor, this is the signature for snow, this is the signature for concrete, this is the signature for vegetation, this is the certified diagraph which is available along the world. If you scan my satellite data through my machine learning algorithm, and if you observe that this type of nature of the graph, I can see that in the picture there are some concrete, there are some sand, there are some soil, there are some vegetation. And then I can choose the vegetation part together, and then further deep learning that I can apply. So which vegetation, is it a forest, is it a man-made, or is it a crop, or is it a kharif season, or is it a crop season? Academically, then different level of deep base of operation. Here my point of attention is that we need, as an artificial machine or even my human being machine, some pattern of the behavior, pattern of the characteristics for recognition. And object recognition identification is one of the important aspect in the advanced level of AI-based composition. If you are able to identify this, then it is very easy to manipulate the further level of interpretation. And this is happen somewhere, as I said, there is mixing crops altogether on a plane surface, and we cannot able to identify. So my simple RGB image or my simple 10 layer image cannot elaborate the difference between these two. Because if I suppose eyesight difference, I cannot elaborate to two objects, three objects altogether. Similarly, the satellite data cannot elaborate what particular pattern of the crop it is and which particular crop is there. If my target is to yield estimation from the cotton in the Parbhani district or in the entire Maharashtra, I need to have to take the survey with the help of satellite data and all. So, spectral signature is an important composition to recognize an object, whether it is a live species or plant species or animal species, it is required. And that is the challenge in the computational technology and algorithm to create the spectral signature of a different type of crop, of different type of level in different type of environment. So how to obtain the spectral signature, which is already elaborated, just like we have developed so many spectrals in our laboratory earlier, which is well marked, which is already patented and is already published. Likewise, in research, there are different signatures by the different country, and they have pool of this particular signature, and that is what the spectral library. Then spectroradiometer, simulator model, and hyperspectral images. These are some of spectroradiometer means what? I can just track the reflectance with the help of the gun, but I cannot able to showcase whether it is a tree or it is a banana tree or which particular type of consideration. So Government of India and worldwide, there are different missions for the agriculture sectors altogether, and they are playing a very, very big role altogether to tackle this. No single country is enough capable till today to handle all type of sectors. So always we require the treaty between the country to country, nation to nation. If I have satellite, geospatial satellite for Government of India, they can scan in one single swath from south to north, 1 kilometer to some kilometer. But rest of the part is not required. So we require a different level of circulation orbital constraints, and that's why it is an international consideration to consider the different level of treaty among the all. So NASA is having, ISRO is having, in Europe also having some space centers and their satellite for collecting the surface level information about the surface. Maybe it is different level of information. And that's why government of NASA in Hyderabad, NRSCA, there is some satellite authorization of the Government of India. They have the different type of lease 3, lease 4, lease 5 data set of images, and through which we can able to identify, even though in Nagpur also, and even though in Pune also, they use some type of data with the help of toposets. So other source of remote sensing data, that is what geospatial. I don't have the much more target. Just I want to set some spectral signature. I can mount my camera on a high level of stick, and I can collect the reflectance from the surface. Or just like an aircraft or airborne or UAV, unmanned vehicle, and some of the ground-based sensors. Concept of deep learning, so once the data is get collected, either in the form of grid or in the form of images, then technological composition start. How to process, how to interpret, how to classify, how to set the object. If the question queries, what is the affected area during yesterday's disaster management happened in the Harashi and some particular districts. So it is very difficult to man to go into the field and take the tape and measure. So we require the satellite data missions altogether to map the surface, to map the land use, land cover. So digital image processing concept required to put that particular image altogether and satellite. These are some of more technical detail. I don't want to take you to more detail. Enhancement technique, then filtering technique, then classification technique, then segmentation technique. There are so many techniques, and to consider this technical method to recognize the pattern, whether this particular affected area, flood area, land area, wet area, hydrological area, agriculture area, mountain area, civil construction area, that we can able to. Again, I am going to skip this because this is the neural network pattern recognition concept. We need to have to set some pattern. If I say the banana, I cannot say the big bhopra as a banana. Banana is banana. That is what the classified signification that we had already adverted with the help of them. So pattern is an important to set the classification of the signature, and that pattern gives you the different type of composition. So some technological constraint detail. This is very deep algorithm that we required to process the data for classification purpose. And once you identify the classified pattern, then we need to have to consider the further line of action. So my point here is that why hyperspectral? Because as I say, in geospatial technological interpretation, hyperspectral data playing an important role. Hyperspectral data means, I will go to the directly that particular slide. Hyperspectral data means you consider this is the cube, let us say 1 by 1 kilometer. There are a mountain, there are a river, there are so many things. And you can scan continuously without having the gap. There is no band gap between the, like say RGB, red color having the wavelength, then green start, then blue start. And in between red and blue, there are so many micrometer and nanometer depth. And if the persistent particle part comes in that particular depth, the sensor cannot able to catch it. And that's why hyperspectral sensor comes into the picture. Hyperspectral data having the huge level of information, huge level of deterioration, and there you require the machine learning and AI algorithm to recover that particular things and put it all together. So this is the multispectral hyperspectral data, more clear I can put over here. This is the wavelength, this is water vegetation indexing signature, and band-wise we can say is a visible band, short wavelength IR band, this is the broadband, multispectral band, each band having some different application. This is the hyperspectral band. That means in the same image, if you have the 3-4 band, in multispectral you have the 7 band or 10 band, but in hyperspectral, more than 100 to 300 band altogether. Each band consists of different image. If you take the hyperspectral say image of this particular campus, each layer gives the different impression. Some layer gives you the vegetation, some layer gives you the internal structure, some layer gives the surface composition, some layer gives the construction. So dimension increases, that means the detail of the information also get all together, but the complexity of the algorithms and processing also required more challenges. NASA has set hyperspectral ultra spectra. So instead of the same band, 2 to 3 wavelength, there is 100 different continuous band, but in hyperspectral there is 1,000. So from so many 1,000 kilometers from the surface, the high altitude, my satellite sense 2 centimeter by 2 centimeter area on the ground truth, and they can easily detect the plutonium, uranium for the 2 by 2 centimeter soil of the seas. Pixel means likewise centimeter by centimeter, x and y axis, because we are going to project the information in 3D into the D form, and we can have the pixel combination. So 1 kilometer by 1 kilometer, 2 kilometer, 2 kilometer. So hyperspectral generally having 25, 10 by 10, 5 by 5, 2 by 2, meter by meter of the size of the ground truth. And within that, you can able to access the information. Why hyperspectral data? Because already we had considered the huge amount of information without having the gap that we can able to collect, and that is what we are going to consider that hyperspectral data is an important tool for agriculture applications. So I will skip this technical part because there is a signal coming from the chair and co-chair to stop. But as I say, I am not a vice chancellor, I am a teacher. My teachers start here to explain earbone, spacebone, these are some characteristics. Spectral range also some characteristics. And application for agriculture, precision farming, stress nutrition, forestry, biodiversity, soil, coastal. These are the various particulars having the different type of sensor available in the market to collect the data. And agriculture environment consideration, I will show in, please pardon me for 2 minutes, what we have done in the last 2 decades. So I am not going to say just the bookish knowledge or from the knowledge gained from the resources. We do have some experience from last 20 years, and already 25 pages already in the particular domain in technological engineering form. So we use the Maharashtra in Phulamri and Taluka, collect some sample, soil sample, we generate the soil sample map, we generate the spectral signature map altogether, and without touching to the soil, we can generate what are the content possessed by the soil, and we can produce that information just like in a soil card. We can give that this soil consists of these type of minerals, and this particular soil is suitable for that particular cropping pattern. So soil sampling data, spectral acquisition that we had done, and this is some more technical detail, and this technical and this publicity also that we have. Second case study we had done in the Vaizapur district in Aurangabad region, because it is a very prone area. On the basis of stress of the crop, we identified some region, and we can develop that. This is the international pattern that we had already filed and completed, granted. So drought analysis on the basis of hyperspectral data. So we use the different data source, we create our own data source, and this is what my earlier students have going into the field, collecting the samples and collecting the informations all together. we developed at that time the complete online application for collection of the data and repository altogether. So spatial data analysis also done, then drought assessment also done. This is the public data which is available in standard journal that we had pulled in IEEE. We may have the access somewhere and we can get. So crop classification we had done, as I say, Udid, Moog, Tur, 3-4 Kharif and 4 Jwar and Bajra also in Maharashtra that we had done and identified this crop. This is what the sensor that we had already purchased in one project. This gives you the non-imaging signature and satellite data and field sector gives. So this is what Wegener Attila crop, Udid, Moog and Jwar, Bajra. So this particular crop that we have studied and clearly identify first time the spectral signature of this crop. So any sensor if you put, they can easily understand this is Bajra crop. So crop classification also done and crop classification pattern also done. The leaf pattern also done. We had developed some sensors. It is again patented by the Australian government and this data is available for everybody's use. So what I say, the internal structure, external structure, characteristic behavior and canopy, these are 4 or 5 parameters for the recognition of the crop and on the basis of that we can able to. So this data is available with us for somehow some specific region and level and we are already taking it ahead. So challenges are always there. No technology is supposed to be found fulfilled. As I say, there is a hyperspectral data, but there is a hyperspectral data also. And if the data size increases, my algorithms also require the more challenge to produce. As I say, Mani sir and my thing, Agarwal sir also, Sahu and me and some 24 people were in the one NASA project of the DST of 35 crore. And some of the work is already that we had published. And with the help of Python, we had denoted to the government of India the open source for hyperspectral data analysis 8 years back. So the last 2 slides, why quantum? Because my digital system, even though the computers, even though the laptop, even the sensor having limitation today, I cannot elaborate the whole world data all to the single click. So my digital limit is over. And that's why the world take the another call to digitize the information, and that is what the quantum. So quantum technology for agriculture, quantum technology for healthcare, quantum technology for any application, but that is very premature stage. Government and we has secured the 6,000 crore rupees for the quantum mission altogether. So if it is happen within the next 1 decade or 2 decades, maybe it will be the again world wonder to meet out the challenge of everybody's life to make it very simple. So this is just for sake of curiosity for people. So quantum technology in agriculture already work started by the European countries and some China, because China has already launched 4 quantum satellites and they are going to collect the information, start collecting the information. So these are some of my contributors. They are working in different locations in the country and they have put me proudly to say that for their research work and some project work to altogether. So we have to put the KVK research group. There are 48 students already that I had produced in engineering and technology. Out of that, 25 are in this particular sector, remote sensing and GIS. So this is what published patent particular this domain, granted patent 2, this is old data, patent is already patented and 50 publication altogether. So thank you for patience listening and giving me this opportunity to you. Yeah, please. Thank you.
Open for discussion if anybody wishes to.
Yeah. So that is what Maharashtra Secretary says that they are just going to wonder here because एक मराठी मध्ये म्हण आहे मराठी लोकल का असेल अमृत गट भरलं तुझ्या घरी का वन वन फिरसी बाजारी. People are there in nearby you. You have to just tap and identify. Not to go to Japan, not to go to America. It is nearby you. And use it, tap it and go ahead. That is the last note from my side.
Thank you very much, Professor Kale. And in fact, we have been meeting in different forums, particularly AIU.
Sahu was one of my colleagues.
Ah.
Yeah. No, IIT Mumbai, Kharagpur and others also. Yeah.
Let's have, thank you very much for very vivid and very clear thought and your all experience. We all understand that once professor starts to speak, very difficult to stop. But good thing is that we have 4 centers of research and extension in Aurangabad, Chhatrapati Sambhajinagar, and another four at Jalna, in Jalna district, Badnapur, and we have Bajra Research Station at Bajapur, where you are saying that you have collected data. It will be very nice actually, and my dear friends, just after this, we are going to sign an MOU, because when we met, this is again, let me tell you, it's a coincidence. Recently I was traveling from Delhi and Darsab also, and we met at airport in flight. Coincidentally, हम दोनों की सीट बगल में पड़ी, हम आके डिस्कस करते रहे, और उसके बाद वहीं डिसाइड किए कि MOU करना है, वहीं डिसाइड किए कि ये हमारी कॉन्फ्रेंस है, इसमें आपको आना है और वाइस चांसलर के सामने ये व्यू रखना है. मतलब हमारा कहते हैं कि जैसे कि नॉलेज सब जगह इधर उधर घूम रहा है, उसको देखने की ज़रूरत है. और कई बार वी आर वर्किंग इन डिफरेंट डोमेन्स, so that's very, very important that we try to get connected. What is important nowadays, I call it a message that CIC, collaborate, innovate and commercialize. So collaboration is buzzwords, and that's very, very important. Sanghe Shakti hi means you are united, you are strengthful, you are divided, you are unstrengthful. So that's very, very important, and I think not much question, but
you can put me. I have not shared my Vice Chancellor email because huge number of mail coming every day. kvkali91gmail.com. This is my personal mail, which has already been done. You can interact me. You can ask me. Even though my co-group, there is a KVK research on another side maintained by my research student, and whole data and techniques are available. Now we are in the fourth quadrant, entering into the quantum technology for agriculture. Yeah.
Just one query actually. It was anyway very nice and clear presentation. We are more interested in identification of the soil properties or characteristics with the help of just spectral response actually.
Correct.
Maybe would like to.
I think you have field spectroscopy in your laboratory.
Sorry?
You have field spectroscopy in your laboratory.
We right from field spectrometer
400 to 20 nanometer range.
And drone based hyperspectral radiometer. Thanks to Agrawal, who used to be National Director of program.
Right.
So we have hyperspectral signatures, libraries of crops, when they are subject to different stresses and during different growth stages. That is no issue. Yeah. But we are mainly interested in the soil spectral signature, through which we can identify the soil actually. So anyway.
Yeah, sound good. Yeah, it is possible, 100% possible. Yeah. And different stakeholders should come together. Huge resources also that we require.
Yeah. Okay.
We'll do. That's why we already come together with you. Yeah. And now with the Parbhani. Shall I come on that? So this call open because under NEP 2020 agriculture is not coming to the force. But for research already we have signed up the different team for different country. And we can already open for taking the call as an honor. So just like Maharashtra, our technological university is the entire state. As you say that your region, we have the Mumbai headquarter, Pune headquarter, Sambhajinagar headquarter, Nagpur headquarter, Amravati, Nanded, Solapur and Kolhapur. Total 9 regions we have. You can just visit our university website dbatu.ac.in. So the location is already you can easily track.
Good afternoon to all. Just now we have witnessed what are the applications from engineering sides, especially to resolve the problems of farming community. Now university will take this opportunity to sign the memorandum of understanding with this technical university. So I invite Honorable Vice Chancellor Sir Karbari Kale sir to join the dais. I also invite our Director of Instructions Dr. Aseva sir to join the dais and to have the signature on MOU, and I request both the Honorable Vice Chancellors to exchange this MOU. Thank you, sir. Thank you, sir.
I am here. I am here to present vote of thanks on behalf of Vasantrao Naik Marathwada Krishi Vidyapit Parbhani. First of all, I express my profound sense of gratitude. First of all, I express my profound sense of gratitude to respected Dr. Professor Dr. Indramani Sir, Honorable Vice Chancellor Vasantrao Naik Marathwada Krishi Vidyapit Parbhani, and Dr. M.S. Chauhan Sir, Honorable Vice Chancellor G.B. Pantnagar University, for chairing the session and for conduct of the session and critical suggestions and guidance. I am also thankful to the rapporteurs of the session, Dr. R.P. Kadam Sir, Dr. P.S. Kapse Sir, for taking the proceedings of this technical session. I am also grateful to all the keynote speakers for their brief and nice presentations, without which it was not possible to complete the task. I am equally thankful to all the dignitaries of this group for their active involvement and participation. Last but not least, I also thanks one and all who directly or indirectly involved in making this session successful. With the kind permission of chairs, I declare that this session is over and second session will start right after this session. And also by mistake, now I would like to request our Honorable Vice Chancellor Sir to present a memento to Professor Kale Sir, Honorable Vice Chancellor. Thank you, sir. I will hand over session to Dr. Bhutada, madam. Thank you.
Good evening, all respected dignitaries. On behalf of VNMKV Parbhani, welcome you all in a technical session second, farm mechanization, sensor, IoT and robotic of 17th National Symposium of Indian Agriculture University Association.
Hello. Hello.
Chairman for this session is Honorable Vice Chancellor Veer Chandra Singh.
Hello.
कोई बोल रहा था. Honorable Vice Chancellor Veer Chandra Singh, Garwali, Uttarakhand, University of Horticulture, Forestry, Barsa, respected Dr. Parvindra Kushwal Sir, please be on the stage. Kaushal Sir, Parvindra. Next, Honorable Vice Chancellor, National Dairy Research Institute, Karnal, respected Dr. Dhir Singh Sir, please be on the stage. Rapporteur for this session is Dr. H.W. Avari Sir, Chief Scientist, Water Management Center, VNMKV Parbhani, and Dr. V.K. Ingre, CAET, VNMKV Parbhani. Now I request Dr. Shilsagar Sir, as a customary, I welcome for the chairman of this session.
Welcome to second technical session, and with me in the co-chair Dr. Dheer Singh. I am Professor Parbhani.
Again, I request Dr. Shilsagar sir, please welcome Dr. Dheer Singh sir, Honorable Vice Chancellor, ND RI Karnal. Now I request Penke sir, please welcome rapporteur of this session, Dr. Yash W. Avari sir and Dr. V.K. Ingre sir, by offering a bouquet. Thank you all respected dignitaries and chairman of this session. In this session, we have 5 keynote address and followed by panel discussion. Now I request respected chairman sir gives opening remark and just follow.
Yes, second section is always short, It's tight rather. Thanks to the chair and co-chair of the first session. So welcome. After the lunch, we had a short discussions in the technical session first. Now we move to session 2, which is on farm mechanization, sensor, Internet of Things and robotics. We had a reference in the first session by Dr. Kale also on this. The speakers, as I already said, that we have 5 speakers, 4. Should we get 10 minutes each? All the speakers are here, yeah, online speakers? There.
Yes, yes, I am online.
Online.
I am online.
First the online speaker.
And I request that online presentation be taken earlier.
So I also welcome my co-chair, Dr. Dheer Singh. You would like to say something, sir?
No. Thank you, sir. I think this is also a very important session, and the title is the Farm Mechanization, Sensor, TIT and Robotics. I personally believe this farm mechanization is not agriculture, but across the allied sciences also is one of the important actually. I think the previous actually the speaker itself, we have to be join hand. Agriculture, we have to be join hands with the different institution to make this mechanization and sensor biology, TOT and robotics. Because across the world it is already too much actually advancement has been. For example, we have already that's animal husbandry, and in India still there is not much mechanization. This is also rearing animal is also very difficult nowadays, because family is not going to be used play with the animals. And if you go to the Ireland also, the 300 animals and one robotic is going for the milking also. I think in India, only the robot somebody is going to try, we have to import. Again, it is going to be very costly. So these actually these are the topic is very pertinent to a particular time, and we must actually start working, because our agriculture system, what we are working, it is not much actually diversified. But I think now the time comes that we should be diversified. The government of India has already started in this business, and agriculture, the AI and robotics and all sensor business, they have already started actually along with this IITs also. And like agriculture in IIT, this has been given to lead institution in Ropar IIT. All the Vice Chancellor, I will urge actually Vice Chancellor, we have to be identify the specific area, and we should join hand with actually other institution to make this this particular area. So that's I would like to congratulate the Vice Chancellor of this university organizing this particular important area, and we should really thanks actually to be, because we are never the late actually, we are late but never the late. So with this actually remark, let us invite the speaker, and I think we should give the 10 minutes, because we have to make a time management also. So let us give 10 minutes if you agree. Thank you very much, and we can look the chairman, co-chairman, to invite the first speaker, please.
So our first speaker, Dr. Shivram, IIT Pavai. Topic: Smart Robotics Technology for Crop Health Monitoring. Sir.
Good evening. I'm very humbled, honored to be in front of all of you. Unlike the rest of you, I have no background in agriculture. I'm a computer scientist who specializes in artificial intelligence. This is what I'm going to tell you about. A little bit about AI. I don't know so much about agriculture, so the little bit I will talk about it will be more the intersection of AI and agriculture. But in so doing, the problem that I really want to motivate, I think which has already come up a few times today, is the human resource problem. I represent eYantra, which is an outreach program, and I think we can help you, right, in this collaborative effort. So AI, right, is something we're very familiar with in the last 5 years or so. It has entered our daily lives. We can speak in natural language to our phones. There are self-driving taxis in the US now. Robotic surgery is something that has become standard practice in some situations. Some years back, there was a demonstration that the game of Go, much more complex compared to chess, was sort of overtaken by an AI program, okay, built by a company called DeepMind. So all this has been happening. What really has prompted this in the last 5-10 years? Growth of the internet, right, is one thing which has made a lot of data available. The amount of data has grown exponentially. This has happened in other sectors. It is also happening in agriculture now, I would imagine. Sensors, right, which are gathering data. There's cameras, there's IoT sensors, there's CCTV, right, so many things that are gathering data, putting it on a cloud. All of these things create the right environment. But technically speaking, the one algorithmic idea, the concept that has led to AI becoming so effective is machine learning. So what really is machine learning? So imagine I show you this picture which has two axes, x1 and x2. It's got some points which are called plus in green, some which are called minus in red. At this point, suppose I give you another point over here which does not have a label, plus or minus. What would you call it? Do you think it's a plus or a minus? Would you predict this to be a plus or a minus? No puzzles, I'm asking a very commonsensical question. Sorry? Nothing? Okay, no, it's not a quiz. I guess most of us will call it a minus, right? Implicitly what we are doing in our own minds, right, is actually a mathematical operation. We are drawing a line separating the pluses and the minuses. If I had asked you some point to the left of this line, you would have called it a plus. To the right of this line, you would have called it a minus, right, presumably. Now the point is, we are not needed in order to do this operation. A machine could do it. So machine learning is all about this enterprise where all of this input data is given. A model is trained. In this case, the model is that line. And once you have a model, you can make predictions, okay? So this general paradigm has become very well understood. It doesn't have to happen in two-dimensional space. It can happen in very, very high-dimensional space. These can be images. These can be pieces of text. There's applications to weather prediction. Is it going to rain today or tomorrow? It's pretty much the same point. You see a leaf. Is it healthy? Is it not? All of that is a manifestation of this same technology. Now, the one thing that I want to sort of use to motivate my talk is, you see the good results and the big successes. What you don't often see is behind the scenes, the extent of domain knowledge that is needed for making any of these big applications work. A very classical example is that of IBM Watson. IBM, of course, is the big American company, lots of money. They built this program for question answering. They also said they had tailored it for disease, human, right, medical disease diagnosis, particularly cancer. Very highly touted, lot of publicity. And then later, right, within a few months it came unraveling, not so much in the US, right, but in other markets that they tried to put it, South Korea being an example. Why? They had not adapted their recommendations to South Korean sort of data sets. They made mistakes like recommending medicines which were okay in the US but which were not covered by insurance in South Korea, right? So many of these things, right, which became failure points for them, were on account of them not working closely, right, with their South Korean counterparts. They did it somewhere else, tried to implant it, it didn't work. Here's another example. This was the game of Go that I told you about, built by DeepMind. in this case, notice like this was done by a team of 20 excellent computer scientists. One name that I have identified in blue is not a computer scientist. This is a professional Go player. So when they built the program using reinforcement learning, they hired, right? They worked with a domain expert, right? Spent time with them, right? And made this happen. So the importance of having knowledge from the domain is very crucial for any enterprise where AI has to succeed. I can tell you about some of my own experiences, but I don't have the time for it. What does all this mean in the context of agriculture? I've told you about the AI side of things. Now, I think we've already heard there are so many opportunities for AI to make a positive influence in poly houses, in pest detection, in automating labor, drudgery reduction. This I have heard, I don't know, I traveled to Coorg a month back, right? The coffee planting people there, one of their big scares is elephants, right? Coming and doing something. So they say, can AI detect elephants, drive them away? So we have a very variety of problems. Now, in each of these, right, of course, if we have to develop good solutions, we're going to need solid domain knowledge. But then the question arises, what really is the domain over here? If you look at it carefully enough, look at the variety of crops, right, that is grown in our country. You could be growing dal in Bihar, vegetables in Ooty, Baramati, sugarcane, horticulture, Himachal. Soil types, your soil can be red, black, sandy, right, whatever. Your climate, right, can be all right, medium climate, it can be monsoon. In Konkan area, it can be extreme heat in Rajasthan, it can be foggy in Coorg. So there is so much variety. So it is really like, it's really, I think, impracticable to be thinking of this as one domain where one person or one unit will have all the knowledge, right, to be able to provide and build effective solutions. The only scalable, sustainable way, right, of building technology for all these different conditions is to diversify, all right? So, of course, we've been told to make in India. This is something that we should take up. But what is really the way of making in India? India is so diverse. So this is maybe my most, I think, central slide. So what I'm proposing is that if we have to make in India, right, we have to make in Guntur, we have to make in Jorhat, in Bhagalpur, in Durg, in each of these places. It is not possible to sit in Mumbai alone, right, and build the technology to work in Coorg, right, or in Northeast. We need, right, every place to have coverage because that is where the local conditions are covered. This, by the way, some of you might be staring at these names. I Googled for the list of agricultural universities in India. I picked out one from every state. Okay, so many of you might be from these places. Where does IIT Bombay and eYantra come in? In order, right, for all of these places to be staffed with personnel who can contribute the technical know-how, right, we need to have them there. On the other hand, what is happening right now is a lot of rural areas being, the youth, right, are trying to migrate to cities, take up jobs outside of agriculture. So what do we do about it? So my colleague Kavi Arya, who created eYantra about 15 years back, started with this basic observation. It's not particularly to agriculture, but it extends across different sectors in the country. So we have a very large population, there is no shortage of demand, and as somebody sometime back mentioned here, making in India, in many of these cases takes about 1/10, 1/8 the cost, right, of importing. Why are we not doing it? We are not doing it because the HR is not trained, they don't have the skills, the hands-on ability, right, to actually do the engineering, we don't have the technical processes. We have 50% of our population under the age of 29, right, so again, as it has already been said many times here, very critical that they get trained, right, that they get trained in skilling, AI, entrepreneurship and the like. And this is what eYantra does. eYantra is an outreach program. We are fully funded by Ministry of Education. We run various modes of training students, including a robotics competition, project-based learning. We emphasize on working with your hands, okay? It is scalable. All the software we use is free, open source. There is no technology to sort of buy other than the hardware. We teach the students technical skills, soft skills, right? They need to know how to communicate, how to manage time, how to talk to others. And for the future, right? Think critically, learn, do research, and so on. At this point, I'm going to play a small video, okay? This is one of the eYantra interns who's sharing her experience. It'll take me another 2 minutes to finish, okay? I'm mostly done.
I personally like eYantra a lot because in this you can actually practically implement things. It's very different from the theoretical knowledge that we learn. For example, we have studied control system in our course, but when we actually tuned our drone using ROS, it was entirely different. How the KP, KD, KI are actually affecting the drone, what is its transfer function.
Earlier, the projects were just for the sake of examination, but now projects are now they are thinking as a out product, final product, furnished product. So that is the biggest achievement for our college by setting up this ELSI, that students are thinking for end product, sellable products or patentable product.
Can we go back to the slides? Okay, so maybe just make it full screen. This gives you a glimpse of the kind of technologies in which the students have been trained: image processing, embedded systems, functional programming, ROS, softwares like for designing, Blender, multi-agent robotics, right? Many of these different themes, IoT being one of them. I'll show you another video of the actual robots built by these students. Can you play the other video, please? So remember, these are students who have come on board for about 6 months. They have gone through our training. So they do something in simulation. Same thing gets done in hardware. All right, so that was a glimpse. Sorry. This is spread of Yantra labs. There's 500 plus of them all over the country, including many in Maharashtra. In terms of a summary, about 2.5 lakh students have been trained, 3,000 colleges. We have robotics competition. We have something called an Innovation Challenge. We have this lab set up, right? So if there's any sort of interest, right, you should reach us. I'll tell you how that's possible. Many Yantra alumni have gone on to start up their own companies, right? There is this one that uses drones for maps of mines. There's another person who has done some work in solar energy. So they pick up vital skills, right? And these ideas, they get the confidence to go forward and actually do something with it. So I'll conclude with this. Yeah, this is the final slide. So the gist is that AI is now quite mature, right? There's off-the-shelf tools to use. The challenge is not really the technology itself. For India, at least right now, it is the lack of personnel, human resource for building for our own needs based on that technology. So we need professionals trained both in agriculture and AI for building our agri-tech, which means we would really like for agricultural universities to collaborate with engineering tech universities. IIT Bombay in particular and Yantra would be very eager to work with you. Concretely, if you want, you can scan this. It will take you to our page. I'm Shivaram, right? You can send me email. Ajit Harpude sitting over there. He's actually going to be here today as well as tomorrow. Okay, so you can talk to him also about this. But I'm done. If there's questions, I can answer. I hope I can time.
Thank you, Dr. Shivaram. It was nice. I think the time has come to collaborate the agriculture scientists with IT people, isn't it? Time has come to collaborate the agricultural scientists with IT people.
So I think it's already happening on a small scale. In fact, Professor Shende here has, I think, already worked with Yantra a few years back. I think more systematically on scale, right, would help us really multiply the effort.
Any questions from the? Yeah, yes, please.
Mike, please.
Yes, sir, I am soil scientist, Dr. Praveen Vaidya, Associate Dean and Principal, College of Agriculture, Parbhani. I am also working on remote sensing and GIS, and I'm more interested in machine learning technique. Because we are agriculturists, we are thinking in that aspect, how to count the number of fruit in plant by using machine learning technique. This is one thing. Second thing is, as a soil scientist, I am asking, because in Marathwada area, different type of soil, even though the sir has developed the map, I am also developing some soil map. But in black cotton soil, there are again 3 to 4 type of different soil. but remote sensing technique are unable to gather such type of data. But in soil survey, I have read some literature in that direction. Machine learning technique will help to identify such type of soil. How will you identify and how machine learning?
So I don't know the answer, but to be frank, the point of this talk is, till you asked it, I didn't know the question either. I did not know that there are 4 types of black soil, right? We'll have to look at what sensor data is available. Machine learning can certainly go beyond human cognition in many senses. It will need some analysis to answer your question, but thanks. Yes. That's exactly the point, sir. We don't know the real problems to solve. We solve imaginary problems. We solve problems that Americans are formulating for us. Right? Our own students should be solving Indian problems in our own backyard. So give us our problems. Absolutely. Thank you. Yeah.
I think it's a very good point that has been raised. I would request the Vice Chancellor, they should make some brainstorming nearby because this Bombay is very close to them, and then different institute, department, what is the problem, and then invite them and make the integration together and start the projecting. Is very rightly said. We are solving problem of outside and all the problem. Why not we are solving our condition, our Indian condition? So this type of actually the initiative will definitely make the closer to actually the different department. I would request again and again that the Vice Chancellor has to make their Indian problem in agriculture, livestock, fisheries, whatever it is, and then invite actually whatever the expertise, and then Government of India has started this program in agriculture, AI and agriculture.
Or better still, send your students to us with those problems.
Thank you, Doctor. Now our second speaker, Dr. Syed Ismail, isn't it?
Just a minute, sir.
Yeah.
I request chairman of this session, please offer bouquet and memento to the speaker, Dr. Shiv Ram, sir, IIT Powai.
Can we take it at the end?
Okay.
No problem, because that will save the time. Yes, second speaker, Dr. Syed Ismail. Yes, sir. ECO, Radiant Embedded Solutions, Director SIFA, Sanpra System Private Limited. The topic is automation in sowing, weeding and harvesting operations. Sir, you have the 10 minutes.
Just 2 seconds about me. I'm a PhD in agriculture engineering, and I've worked with the industry all my life, especially in controls. And 8 years back, again, I pulled back into agriculture. I started with agriculture, spraying control for Germany. I was exporting. I was pulled back by my teacher, Gajan Singh. And this particular one, farm machinery, last year we submitted to NAS a report which includes about 15 of the experts throughout India. So I was one of the person who compiled it. So I will give some important gist of the points, what is required for farm mechanization today, which is the topic. Okay, I'll go through. First slide, please. Let us go through, because only 10 minutes are there. I'll go fast through, only give the important points. If you have doubts, you can ask me. First, see. So let us see the agricultural production right now. Everybody talks about production. We are, like morning people told, we are overproducing almost all of them. Okay, you see the sugar down there, top sweets. These are all the data from 2020 or till 23. The current data. I will share the slides with you, all of you. Then you have also here the current scenario of the deficit. We have only edible oil is the deficit. I think down, if you can remove my photo, you will know. Milk, we have a production more. Meat, we have production more. Everything you name it. Cotton is a bit less now, in the last year especially, 23. This is the actual data. Most of the data from Niti Aayog or from ICR only. I will share the whole details to you. Next we see the challenges what we face. A very important challenge is soil health. You can see on the left side is the main nutrients what we are lacking in the soil health. Right side you see the micronutrients. See, micronutrients are very similar to the global and India. Very similar because we are using similar fertilizers. This is a pity. Because I think 15 years back, I remember Gajan Singh asked me to make an instrument for micronutrients. So to measure now, you see, that's a challenge. Now you have another possibility is land degradation. This is the biggest problem. People don't talk about this, salinity. They don't talk about land degradation because of water. Water erosion. That is the highest killer. Very less people talk about. See, we have already only about 40% of the land we are using it. 46% around. So the land degradation is very fast. How to stop it? Mechanization will help. That's where we are going to come ultimately. This is our challenge. We have to do it. Another challenge we have is the food waste. Very high food waste. Starting from 6% to cereal something and up to 16% of fruits. You got all the data again from Niti Aayog, all the official records only. And this is not from farm to table. Farm to fork it doesn't mean, because there we have India has very high wastage, household wastage. So we are not talking about household wastage. We are talking about how to stop the wastage, food wastage. You can see almost all the crops. This is the basic problem. Again we see here, right side slide, shows you only about 30% of the income goes to the farmer in fruits and vegetables. Rest of them, we have a retailer, we have all the stuff, whatever. And especially a study of, I have done sometime with banana. Wonderful in India how the banana price almost kept, which corporates failed actually. Even I have seen Mahindra fail in 5 farms of banana, how to grow. So we have to do something for this food waste. Next slide we have, important is the biomass. How many of you thought banana leaf, banana plant biomass, 60% is wasted in India? It's a huge, we talk about only burning problems, and that also I given the burning problems, how this burning problem can be solved. Because there is another internal, I interact with a lot of professionals from universities, from IRI, and everybody. So I know most of the people and also industry with Amma as well as with the tractor industry. So I see the biggest problem what we have is the biomass is India big problem. We waste a lot of biomass. Burning is one of the issues. So we already have mechanization solution for the biomass issue. So we will see them also and how to go to the farm mechanization to come. Like the title they told, seeding, weeding, harvesting, yes, but this is all around that. Next one, farm mechanization. Farm mechanization.
Hello. Hello. Hello.
I can talk now.
Hello.
See, farm mechanization around 47% in India. I think it's very difficult figures to understand. We have only tractorization.
Hello. Hello.
And tractors are not used by smallhold farmers. They cannot afford it. Reality. And we have the reality problems again only in Maharashtra, because I worked with Pokhara project for 4 years as a consultant of NAPCONs. So I know the real problems of customer hiring centers. So they have the problem spare parts, taluka level only. So we have the farm mechanization has done what has done is very first farm mechanization what India has done is first of all giving proper water, and second is threshing. This is how it started, historically when you see it. Now it comes still maintains a similar level. It has not gone. We'll see that. I will not go to all the stages. Time is not there. Like animal husbandry, poultry, 0. Milk, 0. milk production will come back, and vegetable fruits, zero, fish, almost none. So we thought of farm machinery only with tractorization till now. And we need rest of the things down is there also soil health, storage, input optimization, biomass, land degradation, energy efficiency. Somebody talked about, I'll show the figures to you. Now farm mechanization till now, till last year probably, everybody was telling how many kilowatt of power, including Bhopal, is giving kilowatt of power, increase it, you will get more productivity. Yes, it is true to an extent. But right now we are reaching 1 million tractors production. India is the biggest producing tractors, agreed. So it comes about 10 hectares, 1 tractors almost will come. So you don't see that much of tractor in the next 10 years. It will stabilize only. Now, why we need farm mechanization? The first point is important. To enhance the profitability, dignity, and sustainability of farming. Second one is to attract and retain youth in agriculture. Without farm mechanization, you cannot do that. Third one is to address the emerging problems. Like we talked about all the problems, what we saw already, those problems to emerge. This is farm mechanization. Let us see what farm mechanization can do. Soil health restoration it can do. Input use efficiency. Okay, input use, we'll see that a little bit later, I will show you. Water productivity can increase. How many people have talked about AWD or root zone optimization and watering? Very less. Yes, we'll talk about water also one slide for about 30 seconds. You have natural resource management, NRM. In Pokhara is one of the projects I have seen, NRM is done a little bit. Still we have, India is a very vast country. NRM we have to seriously think about, especially when about land degradation. Post-harvest management, less done than what we could do. That's what I would say. Allied sectors, husbandry, poultry, forgotten till now. We come back to tractor industry, 45% of tractors are used still for land preparation. Okay, land preparation, tillage, which has no relation with productivity. For the last 50 years, people know it already. We'll come back to that. So, and for transport, mostly tractors. It's a symbol to have the tractors. The government scheme, as I told you, it doesn't really help. Crop varieties, when we make farm mechanization, be careful to make, machines can be used. For example, cotton, you have multiple picking, which becomes impossible. Soybean, the height clearance problem. But I know last 2 years back, Parbhani released a variety which has got a higher, in Pokhara I come to know that. But still it's not properly, extension is not done. Sugarcane, with sugarcane, still manual. We're talking about 20% harvested, planting everything. Abhi bhi UP mein parchi system chal raha hai. Okay, just imagine sugarcane. That is the reason youngsters don't want to be in agriculture.
Sir, थोड़ा short करिएगा time.
Okay, I can stop it anytime. I see you are the chair. I can stop it. I can share it with you. You can see it. 80-90% of water we are using. Okay, I will just one slide, 1 second. I will talk at least. So drones in agriculture, foliar application we tried.
now you are free to answer, sir. You can take the time for the giving reply or presentation. Thank you, thank you.
Field, if you know a hot pan, it's gone broken most of the places. In Bengal, everywhere it's broken. It's no more useful for paddy cultivation, some other field. And the problem is the tillage damages a lot of things. You don't require to till the soil at all. You don't require. So you have already have seeders, Happy Seeder, for example, from Punjab, PAU, made Happy Seeder. I worked with Happy Seeder also with Dr. Sidhu about 5 years back. So we make tracking system for the Happy Seeders so people can locate. Utility is different problem. The Happy Seeder is not available like that for other crops. We don't have crops. See, I try to make farm mechanization you want, make the crop varieties that are compatible to the machinery. So there must be interaction between the departments. See, I see agronomists, they don't talk. See, control environment agriculture, correct? Polyhouse. How many polyhouses working? I had a big, so polyhouse the problem, engineer must be there. मैं आ रहा हूँ मैं इसलिए ये खड़ा है सबका साथ सी sir I'm not against I have a lot of publications pattern I worked with universities then I went to industry and now also with universities most of the university people in Maharashtra know me also and I'm telling you I'm not that problem comes with we have to change a little bit. Industry has to 100% change. And universities also have to adopt the strategy. For example, farm mechanization, I'm putting the problems to address. Okay, one of the problems is water conservation. Okay, you have drip irrigation pipes. Night I have seen people going in Baroda, how the farmer will irrigate the field in the night time. Because the walls are 2 lakhs, 3 lakhs rupees expensive. So we try to promote the university to develop something low cost for them. So every problem, what it will formulate, there is a solution. Only we have to look for it. And I'm willing to help. I think most of the people will also know me here, some of the people. You tell me, I'll try to interact with the industry and you also together. That's one of the things as a retired person now, running off the industries, everything I'm doing. And that's what I told you last time. There are so many people, including CAA, all involved in preparing the report. I think I'll share the report. It's already published report of the NAS report about farm mechanization. That contains everything what you have to do, even the university and industry. Thank you.
Thank you, Dr. Ismail. Those who are really interested in such of type of activities or concerns, please discuss individually, bilaterally. Now, of course, because of the time constraints, we have to. Now, the next is Mr. S. Arun Kumar. Sir, you are from Research and Development Specialist, Hexagon.
Yeah, representing Hexagon.
Yeah. SITSA Center for...
Slide, please. Thank you, sir. Yeah. Good evening, all. Good evening, ladies and gentlemen. Thank you so much for giving us an opportunity to present our concept or our project termed as SITSA. So probably while the slides come up, next slide, sir. Thank you. So this is a project where industry, scientists, academicians, and a lot of companies have come together. iValue is a front-ending company who will be representing the CIDSA. It's an AI-enabled center, which we term it as Center for Innovation in Digital and Sustainable Agriculture, in short CIDSA. So this is our center wherein which we focus on various agroclimatic zones across the country. We go deep into the specific problem, very specific to the local region and local area. We try to understand major challenges that is associated in that cluster or that region. So that's been the primary aspect of the CIDSA, because we all understand over here in this forum that there are a lot of challenges in agriculture. We need a lot of tech. We need a lot of ground level knowledge in order to integrate and bring a realistic solution which will empower so many stakeholders. Like you have farmers, you have students, you have scientists, you have various other government agencies and whatnot. So all of them have to be taken on a common platform or a common board. So about 44 plus companies have joined hands along with a lot of industry recognized equipment, software, systems and processes which can be widely adapted across the various zones within India and its group. So coming to the main goal of the CIDSA, this is to empower and nurture the next generation students for agriculture, because we all know students are moving away. We all keep saying this, but we have taken a step forward to tell them, hey guys, look, there is a lot of tech involved in agriculture and it can give you a lot of job opportunities across India in various companies. And that's primary goal where we are trying to empower the students within the universities, colleges and various other forums, where in which they can get a hands-on experience on these tools and technology and drive their future and get confidence on their future that yes, agriculture has a lot of innovation and tech involved in it. And apart from that, yes, of course, we reach out to scientists, we reach out to various consultants, we reach out to a lot of FPOs and KVKs. So in the AI-driven digital stack which we have integrated in the CIDSA, so it can address to soil sciences, it can address to the plant pathology, horticulture, agri-crops, any crops, it can provide a lot of solutions, and primarily it's an engine which is a data-driven engine, and it can give a localized, I can say, solutions. So how does this work? So typically our CIDSA is a hub and spoke model. Now as you have been going through the sessions, we all understand that you have a GIS layer, a remote sensing 10-kilometer grid. Then you have a drone-based technology wherein you have to do the survey and get the data collection. Then also you need to have a ground level IoT-based sensors or the transponders which will send the signal. Now CIDSA specialization is, it will assimilate and capture the data from all 3 points and build its local agri stack for a radius of within to 50-60 square kilometer. That is what we have developed, that is what we have proven. So by doing this, we will get into an accuracy of 1 meter by 1 meter at the ground level. So that's a 3-layer integration that we do, and we will be able to reach higher accuracies, and we'll start working with a lot of FPOs, KVKs and various other entities who need the data from the local region. So precision farming, how do we achieve it? Farm mechanization, as today's topic is well defined. We integrate sensors, we integrate motors, we integrate ECUs for the tractors, we in fact build autonomous level 6, level 7 robots within CIDSA. We train students how to build that. We train students how to program an ECU. So these are the various facilitation that is done for the drones, for the machineries and various other equipments. And by doing it, we'll be able to achieve this precision farming for any crop. So that SOP, everything can be discussed based on the scientist or the farmer and the student's interest. So that way, crop soil health assessment, pest weed identification, various certifications that is required in order to export. So right from land leveling to post-harvest management packaging. So we have various processes, equipment, softwares, hardwares provided by the group of companies towards this project. So iValue is a Bangalore-based, Bangalore headquartered company. Proud and happy to say that today our stock got listed in National Stock Exchange. It's the same day. So thank you all for that. So it's present both nationally and internationally under iAcademy Skill Development Division. This has taken an initiative to bring up such projects called CIDSA. And lot of technology partners. To give a quick brief, Hexagon is our primary partner who works with ISRO installing the ground transponders to send the signal back to the remote sensing satellites for corrections and various other aspects. So we use the same technology in the SITSA at the ground level. Then we have Earth Now, which does the AI-based and ML-based analytics for the GIS assessment. Then they sell their data to insurance companies, fertilizer companies, and various other companies for assessments and other aspects. So ANSYS, there's an engineering company which helps you develop food processing equipments, which helps you develop machinery, which helps you develop sensors, and various other, agri-related specific, I can say, applications. So Mitsubishi, Kawasaki, in short, this is the group. So all of them have been large contributors towards the technology in terms of hardware, software, services, and various other framework. So with this group, we have been able to successfully develop the pilot, launch it, and fine-tune it, and now take it across the country. So probably I would quickly take across a video, sir, with permission of you. 2 minutes I'll spend on video. Sir, if you can play the video, please. So I'll be showcasing the first center here in Bangalore. So this was the pilot which we took along with Government of Karnataka. Now we have signed up for 7 centers in Government of Karnataka, and will be shortly enabling another 2 centers in Karnataka. The first one. So this is a pilot center, SITSA, which we had
the Center for Innovation and Development in Smart Agriculture, SITSA, is a novel, multi-phased initiative pioneered by the University of Agricultural Sciences, Karnataka. The university has been designated by the Government of Karnataka as the host institute to pave the way to smart agriculture through SITSA. The university aims to build skills of the agricultural students, engineers, and entrepreneurs by introducing best practices and latest technologies, with an end vision of making them industry ready.
The Government of Karnataka has designated the University of Agricultural Sciences as a center.
Skip half. Skip half. Yeah, skip. Go play ahead, yeah. So
well,
these are the labs, what you can see at the
Government of
Karnataka. We call this
the
as
lead
farm automation lab.
in collaborating and creating the center of how technology can be learned, how technology can be used in agriculture, and we want that the students to teach the farmers as well.
Based on the hub and spokes model, SITSA Center, as the hub will house advanced technology laboratories, while the spokes, which will be set up near farming clusters, will extend local assistance to farmers. These spokes will also act as extended classrooms to impart practical knowledge on technology implementation. The center will be fitted out with technology laboratories dedicated to agricultural automation, agronomy, smart precision agriculture, agriculture drones, and farm equipment design and manufacturing. These laboratories are equipped with relevant hardware and software tools, and are based on the learn, implement, adopt model, which will train the students in becoming adept at the next generation technologies in smart agriculture.
It is the same tool that we facilitate along with the libraries so that students can work on top of it.
The Agriculture Automation Lab is about automating farms right from tractor operation, land preparation, fertilizer application, spraying of chemicals, and making them less labor-intensive and more productive. Here, the students can avail the opportunity to work on functional tractors and learn operational navigation precision using an auto-steer simulator.
It's an auto-steering simulator. It is connected with a TI-10 display, which is having a hexagon thing.
So we have agronomy lab.
The agronomy lab teaches students to develop an integrated and holistic perspective in handling and resolving challenges pertaining to food production.
Look into it, but I'll give you a heads up of what exactly these labs are.
The students
get into the slides. Thanks. So this is a very practical model because the companies who are involved with us have been into agriculture, and of course Agrawal sir was there during the inauguration of the SITSA project in Bangalore. Thank you for that, sir. It's been a good encouragement for us. So we were recognized by the PM office, a lot of discussions happened, a lot of scientists visited, workshops, evaluation, again trying to improvise it with various suggestions and things like that. So ultimately our SITSA hub This will become a hands-on training center with 8 labs integrated into it. A lot of practical machineries ranging from 10 HP to 65 HP is being facilitated with a lot of implants from land leveling to post-harvest management. Then you have development of these machines using the commercial tools and technology. You have weather station, you have GIS and various other integration services that is facilitated under SIDSA, which will help ultimately the custodians, that is government, students, farmers, entrepreneurs and others. So in short, these are the 8 labs, which is very relevant and specific to even today's topic of farm mechanization and robotics. So here we combine all of them and we use the power of this ultimately to deliver a fruitful result to end farmers. And this is a local stack, or this data custodian will be the university for that 50 to 60 square kilometer operating area, and you can utilize this for various other applications that you wish to. So we have technical training, certifications, course curriculum integrated. This can be blended into BSc, MSc, engineering, MTech, PhD, various other courses, which we have already done in US, Bangalore, out there. So that way, it's a very sustainable project. And also from industry, we have decided not to charge any fee, but we request university to charge the students so that you collect that fee and sustain the center for a long duration of time. So the number of students that we train on an annual basis, between 800 to 1,200 students is what we train on an annual basis, and that is a substantial fund that you can collect. And we also are investing in the project, so we have a portal called Skill Connect, and all the job listings from the industry is directly made available for next 3 months, 6 months, 1 year. He or she, whoever is interested in a particular job which they feel is exciting for them, they can take the course, get into the job, and definitely they'll get a HR round opportunity from the designated companies. So a short glimpse, this is the hardware, simulators, accessories, soil testing systems, fertigation units and whatnot. So this is the way the SIDSA program is derived. 85%, it's a project of about 140 crores roughly. Close to about 85% investment is made by the entire industry group led by iValue. Apart from the 85% capex, which is around 118 crores or 119 crores, we also deploy our industry experts into the center for next 2 to 3 years. That is about 8 to 10 resources are stationed there to do this technology transfer to the end university. So that is also a part of it. 2 more minutes, sorry. And from the university side, we have 15% contribution, which we expect, that is about 21 crores plus GST. That is what we take in, and we expect them to take the technology transfer from our side to them. So in short, that's the SIDSA project, which from last 7 to 8 years, all of the industries, academicians, scientists have been working with and brought in a very practical solution which can be implemented at the ground level. Thank you so much. Any questions? Open to.
Yes, thank you very much, Arun Kumarji. And this is very, not only interesting, important, also especially in the agriculture universities, where the skill development universities are very important when we talk of National Education Policy 2020. Any question from the floor? Yes, there are 2 questions. 3.
Yes, sir.
No,
Like some sort of the collaboration with the government where subsidies will be available to the farmers.
Hello. You said that you could achieve the granularity in precision up to 1 meter by 1 meter. So was it because of the integration of satellite, drone and IoT, or do you have separate satellite product for this purpose?
Hello.
Doing it. Yeah. So there's nothing different. It's the same, but since industries are involved, they are the leaders and champions doing it. So they've done it seamlessly. Yeah. Yes, we have both. Both are available based on what you need. You can take it up. No. So if you say no, yeah, okay.
Okay, from that side. Yeah.
Yes, sir.
Yes, please. You can use mic.
Hello.
Sir, we are working with the scientists, eminent scientists, who make those seeds, who are specific on their particular vegetable crop. We are yet to release. So this was our first pilot. Now there was a great learning for us from that, and now we have improved and we have got into the SOPs actually. So we have drone-based SOPs, very specific. We have the automated tractor-based SOPs which we are creating. We have the robots for grape farm which will do the entire fertigation for the grape clusters. So that way we are very specific and trying to develop it at a specific location. Yeah.
Okay, this year or next year you are going to give the technology?
Yeah, we will start releasing, yes.
Okay, thank you.
Sir, what technologies are available for the field crops?
Go through the slides. So it's a integration of multiple layers. Now you have a GIS layer, you have agronomy best practices with terms of mobile instrumentation, like you have the soil equipment, you have the water equipment, you have the chlorophyll index equipment, you have the refractometers, you have multiple equipments. So based on your SOP, based on your agronomy.
All these equipments are the instruments. How to apply in the field?
That's exactly the training that we are doing, sir, through the courses that we conduct in our labs.
Yeah.
We specifically train how to use the equipments in the field and bring in the data out of it and utilize it for your benefit. Yeah, that's the integration.
Because our one of the scientists, Dr. Kailash Dakur, has visited that Bangalore farm, na?
Yes, sir.
Yeah.
So that's a pilot, as I did mention. There's been a lot of learning, and now we have enhanced a lot of machinery and application which can actually cater to a large group of crops, multiple diverse crops. Yeah.
Okay, thank you.
Thank you very much. Thank you, sir.
Thanks for your
It was
time.
very
Yeah.
nice. Next is Dr. Venkat Mayant online. Do we have somebody here?
Yes, am I audible? Am I audible?
Yes. Sir, Dr. Venkat Mayant.
Yes, I
Sir,
am online.
are
If
you
I am
hearing
audible,
us?
please confirm.
Sir, are you hearing?
Yeah, I am able to hear you, but whether I am audible to you? Hello?
Okay. Okay. Sir, you can start. Say, former Vice Chancellor, Akola, and you are delivering the talk on farm mechanization for small and marginal farmers.
Yeah.
So, welcome, sir, and you can start. And please try to complete in 10 minutes if possible.
Yeah, sure. I don't know whether you are able to see my screen.
Hello. Hello.
Yes.
Sir, will you please share your lift Zalika? He has left the meeting. We will wait 1 minute. माहिंदे सर, कृपया आपण आपली प्रेझेंटेशन आम्हाला शेअर करू शकता ईमेलवर?
I am not able to share the screen to you.
Yes. Will you please share your presentation with us on email? We will share from
Yeah,
our
sure, sure. Oh, sure. Take a minute, huh?
Yes. Sir, we will share email address.
Next speaker, Dr. Manjeet, are you ready? By the time he is ready, I think we can take your presentation. So our speaker, Dr. Manjeet Singh from CIT PAU Ludhiana. His topic is precision and automation in agriculture machinery.
So, respected chairman, co-chairman.
Yeah, sorry. I'm able to share the presentation now. Can I start? I'm able to share the presentation now. Can I start? Or should I wait till Dr. Manjeet Singh?
Sir, please wait for 10 minutes.
Okay.
Mind this, sir, please.
Thank you, sir.
So, respected chairman, co-chairman, worthy vice chancellors from different universities, my colleagues. So, the topic given to me is on mechanization and automations for the precision agriculture. So I will share mainly the mechanization or machines developed by the my university, and now we have started working on this area of the automation in precision agriculture. So I will basically sharing that. So my first slide is that what is PAU at national level. So as most of the straw management machinery which are being promoted by Ministry of Agriculture under CRM scheme are developed, evaluated and approved by the my university, and about 45% of the farm machines which are adopted at national level were prototyped or developed by the university. Recently, Ministry of New and Renewable Energy, MNRE, they approved the design of PAU dry fermentation paddy straw based biogas plant. So now more than 30 number of national farms signed MOA with the university. We have oldest farm machinery testing center. So about 1,000 machines have been tested till date. We have recently developed this NABL accredited semi-automatic online computerized lab for the energy rating of submersible pump sets, and about 350 agro processing complexes have been installed in the region. So this is the impact at national level. Now some innovative machines developed and evaluated and recommended by the university. So these are some 4 technologies which are already adopted by the farmers as laser land leveler. About 10,000 machines are available in the region. pneumatic planter for the sowing of the maize, cotton, and smaller seeds. Then DSR, direct seeded drill, with this, which is having auto spraying attachment, and then high clearance multi-purpose sprayer, specially designed for the cotton. So this is also new innovative machines which recently we developed and recommended. This is for the seeding of the mat type nursery for the mechanical transplanting of rice, because when we use these paddy transplanter, they use or they need this specialized mat type nursery. So this nursery was earlier sown manually. So many labors were required. So now this all operations are done by this tractor operated machine. So this labor saving 90% and with cost saving 65%. Recently this PAU smart seeder, which is basically strip till seeder. So earlier, as Dr. Saeed was saying, that we developed happy seeder, then this super seeder, now this smart seeder is there. So this is now being developed, being popularized by the university. So 16 MOA has been signed with the industry. So this is semi-automatic vegetable transplanter. So as two laborers are sitting on the machine, so this is semi-automatic. This was developed by one of the PhD student of the university. Sorry. So this machine has been modified by the students under one competition, that is by Society of Automotive Engineers. So they modified this vegetable transplanter as automatic. They made it automatic. So 2 patents have been filed on this technology. So we are also doing some work on this manually operated machine. So this machine is good for the vegetable seeds, and this is manually operated, low cost, suitable for small farmers. This is PAU Turf Manager. So this is being used for the cutting and collection of the grass, mainly in the campus, and this is can be used by many organizations or universities for their campus. So then sensing and automation in machines. As first we developed this automatic steering system for the precise operation of tractor operated machines. So this is having minimize missing and overlapping, that is less than 1%. So also driver or operator is having lesser driver fatigue. This is recently developed. So there is another machine which is manually operated paddy transplanter. Now this has been converted to remote controlled paddy transplanter. So this is having more comfort of the operator or driver. So but skilled operator can stand in shade of tree or canopy and can use this machine. This is small tractor, farm robo. So we are developing different machines like spraying system or intercultural these equipments. So we are adding all these equipments with this compact tractor. So this is having maximum load capacity of 150 kg and forward speed of 7 km/h. So then vision-based cart, this is also some students are working on this. So this will be basically vision-based cart or vehicle, especially for the intercultural operations. there is small video. I don't know where this fixed. I don't know where it is stuck off. Okay. Can you skip from that? Okay. So then this tractor with the data acquisition system. So for the different monitoring of the different parameters like drive wheel slip, draft, fuel consumption, fan speed, forward speed, geolocations, all these measurement of data, this sensors are being mounted. So then as laser land leveler was developed and it is very popular, now GNSS based this land leveler. So this is using the satellite data, and this is also used for the finer leveling of the field. This is a GNSS based smart precision sprayer. So this is also having lesser missing as well as overlapping, to avoid overlapping of the spraying. So this is also being developed. Then we are also working on drones. So SOPs for the crops like rice, wheat, cotton, sugarcane. So for the application of herbicide, insecticide, fungicides, all these is being worked on this drone. Then drone for the variable rate application of the spray or for the spot spraying. So this one student, PhD student is working, and patent has been filed on this. Then tractor operator real-time soil sensor. So this is for the EC and compaction parameter. These are the maps generated on the electrical connectivity and the compaction in the real time in the field. I don't know what is the issue. So these are spectral analysis of soil parameters. So different parameters are measured in the field and mapping of those parameters. This is also the different parameters measured by this machine. Yeah, I don't know क्या issue है इसमें. Yeah. Either? Okay. Okay, so yeah. So this is also one handheld soil sensor. So this is giving many parameters like pH, EC and pK. So evaluation of this small sensor. Next. Next, please. So this is machine vision system for the automatic cotton picking. So this is also being developed by the student. Next. Robotic actuator to transplant washroot type nursery. So these some works are being done by the students. So this is for the washroot nursery of paddy using machine vision. Next. This is for the weeding mechanism for vegetable crops. Next. Sensor-based real-time fertilizer application. So this is tractor-mounted and green seeker-based variable rate applicator for the fertilizer. So also patent has been filed and published. Next. These are also sensor-based reflux measurement for the CO2 and methane in rice field. So this is also being done there. Next. Then IoT and sensor-based irrigation scheduling system. So this is irrigation scheduling based on the moisture sensor. So this system is also we installed in the university and being evaluated. Next. So then for the poly houses, these different type of sensors like temperature, relative humidity, solar radiation, LCD displays, all these type of sensors and automation systems are in the poly houses. Next. These are the views of those sensors and automations for the poly houses. Next. Then this AI being used for the modeling of the groundwater depth. So for the different years, this AI-based groundwater depth is being calculated. Next. So then some IoT-based system for the processing or for the quality. This first one is for the honey-based adulteration measurement, and second one is for the detection of the chemicals in fruits and vegetables. So this work is being done by the college. Next. This is IoT-based biogas flush storage system to manage major insect pests in the pulses and kavli chana. So this is also by the Department of Processing and Food Engineering. Next. So then these are some freeware available apps for the precision agriculture. These are available on the Google. Next. So there is comparison between these two apps. One is NPSS, our Indian one, and Plantix. So this is that. Next. Recently we developed this one school on digital innovations for precision agriculture or for the smart agriculture. So these are some objectives, and then what type of focus areas on this digital agriculture we will conduct under this school. Next. So these new two courses we already approved by the Academic Council: Master of Technology in Artificial Intelligence and Data Analytics in Agriculture, and PG Diploma in Robotics and Mechatronics in Agriculture. Next. So this some breeding department or biotechnology, they are working on this phenotyping, high throughput phenotyping. Next. Then potato late blight forecasting, web-based decision support system, Department of Entomology is doing on this. Next. So three-pronged this approach for the development of remote sensing-based model. Next. This is as mission, digital agriculture mission of India, so having different components and budget laid by this. Yeah. So this recently I visited South Korea, so some 2 or 3 technologies there. So this is Orchard Robo Sprayer. This is developed by Korean, and this one is for the sorting of the this garlic. So this was new machine. Hydrogen tractor they have developed. Next. Drone to control wasp and hornets. So this was also new thing. So that's all. Thank you. So if any
lot of work and number of machines have been developed by the university. Is there any question from the floor? Okay. Thank you very much. Nice presentation. Next, we will take online presentation, Dr. Venkat Mayans. Yes, this is the last presentation. Sir, are you ready? Sorry for...
I'm ready. Are you able to see my presentation? Are you able to see my presentation?
Yeah, please, you can start.
Okay. I am trying to go to the slide presentation mode.
Slide. Sir, can you change on the slide mode?
Yeah, that's what I'm trying. It's not happening on my computer. I'm trying, but can anybody guide me how to go to slide presentation, because that's not happening.
That's right side mein there is one dumbbell shaped symbol is there.
Yeah, that's not getting working. Okay. Just a minute. I'm trying that part.
Anyway, we can start.
हेलो सर,
Hello.
82% ऐसे एक नंबर दिख रहा होगा आपको, 82% सबके नीचे कॉर्नर में, राइट कॉर्नर बिलो वाला, हाँ 82%। आइए थोड़ा नीचे आइए, ये जूम इन जूम आउट दिख रहा है सर, और F5।
हाँ, ये दिख रहा है, जूम इन तो दिख रहा है।
हाँ, तो 82% के नजदीक।
82% shall I increase it?
82%
I'm
के
trying that cup, but it's not operating. Is there any other way?
Press F5 on keyboard. F5. स्क्रीन शेयरिंग ऑफ हो गया सर आपका।
ओहो।
Please share the screen.
Yeah.
Yes. Now F5. Press F5 on keyboard. F5.
I'm doing it, but it's not happening. Anyway, if you are able to see my slides, I will start without wasting
No
time.
sir, you are not visible. The screen is not visible still.
कर सकते हैं यहाँ से। ओके सर यहाँ से ठीक है, आप करिए।
हाँ, वहाँ से कर सकते तो कर लीजिए, क्योंकि
Go ahead sir, please go ahead.
Yeah. Co-chairs and all the participants, good evening to all of you. I'm sorry that I'm not able to make it full screen. I know that cup type of thing where I press, I get full screen, but I'm not getting now. Anyway, I will start the screen. Are you able to see the slides? But my topic given to me was on theme of the symposium is small and marginal farmers. So I was asked by Dr. Indramani and given the topic that let us talk on mechanization of small and marginal farmers. Slides are also not moving. I don't know.
सर नमस्कार, तुम्ही तुमच्याकडे डॉक्टर रामटेके सरांचा ईमेल ॲड्रेस आहे, त्याच्यावर तुम्ही पाठवू शकता?
हो, त्याच्यावर पाठवू का मी?
प्लीज पाठवा.
Please wait for few minutes, 1 minute. Huh?
Okay.
Just a 1 minute. I will take only. Presentation is not bigger.
Yes.
Yeah. I'm sending to Dr. Ramteke.
He is sending their slides.
Okay, I have sent it to Dr. Ramteke's.
Yes, please.
Okay.
डॉक्टर साहब आप प्रेजेंट कर दे, प्लीज गो अहेड एंड प्रेजेंट इट फ्रॉम योर स्लाइड
I can go ahead.
नो प्रॉब्लम.
But
By seeing a slide on your computer, you may present it. There is no issue.
yeah, I'm able to see it on my computer, but
हो सकता है ठीक है.
हो गया, प्रेजेंटेशन हो रहा है. आई एम नॉट एबल टू.
हाँ आप यस. डॉक्टर साहब करिए आप इसको. ठीक है आगे.
ओके, मेरा प्रेजेंटेशन.
हाँ आप.
आई थिंक. Okay, thank you so much. I'm sorry for this mishap. I was not able to make a full screen. I was given a topic of small and marginal farm. I will not take much time because I know the time constraint and it's already delayed by 2.5 hours. I think I am Dr. V.M. Mayande, former Vice Chancellor, PDKV Akola. I think most of the Vice Chancellor present in the audience may not be knowing because I am already superannuated almost 12 years ago. That's why I may not be knowing. But this is the topic given to me. Current situation about small farm in India is that as per the statistics, national statistics, we have 86% smallholders and land area occupied by them is 47%. So, and this is the group which is key group of farmers who is secure our food security. The reason is that most of the food crops like cereals, pulses, fruit, vegetables are grown by this group of farmers and they ensure our food security. So this is a very important group and by volume it's a much more, proportionately 86%. About 40 to 50% of our people depend for livelihood on small and marginal farms, especially in agriculture. But the another key important point I would like to pass on this to this audience is that our India's per capita income for 24-25 as per the budget of the government of India is 2,34,859 rupees per capita income, whereas average monthly income of agriculture household is 10,218, which means per capita income of the agriculture household comes to 30,654. You can look at the difference between per capita income of the country and per capita income of the agriculture households. Again, small and marginal farmers, further down, the per capita income comes to 21,000 rupees. So can you imagine a person living his life in 21,000 rupees for whole year? This is where the disparity between probably in the country between the agriculture households and the other households in the country. And this is where my concern is that we must do something that how can the agriculture households live on such a small income. The strengths of the small farms, they provide food security and nutrition. Actually, small farms are more economical to operate. More operationally, they are very good that it can be attended. So higher yields per hectare can be obtained in a small farm rather than the large farm. There ecologically, it has a social benefits because small farm people, they have their livelihood on that and they are better off. But there are challenges. One challenge is the scale efficiency because they are small scale and they are more inefficiently can be operated. So inefficiency of the scale. They have a problem of access to input and technology. There are financial constraints including credit and risk, market access, input cost, climate risk. These are the problems which are challenges and weaknesses of the small farms. Next. Now, are these farms viable? Is this a question mark? And I can say yes, small farms are viable, but only when certain enabling conditions are met. At presently, looking at the per capita income of the small farmers, I think they are not viable. But they can be viable if we can really support this special program for small farmers by improved policy support specially targeted toward the small farmer group, creating a better infrastructure and supply chains, then technology diffusion to small farmers, especially the integrated farming systems models were found to be more providing better economics of the small farms, that to be popularized. Then there has to be a reduction in the risk in the small farms. That's where another component is that we say that small farms are not productive, but productivity is a scale neutral. Whether it is a small farm or a large farm, the productivity doesn't matter actually if you provide all the inputs, right time, right place in the small farm also, they are also equally productive, and it is proven by our experimentation. Then at this small farm, introduction of a small precision robotic machinery and use of AI-based automation, we have seen a lot of presentation just now, earlier this morning and now also, that we are already on that path, that we are already researching on AI-based small robotic models, small models, compact models for small farmers. Next. Now, for mechanization of small farms, large-scale machineries which we developed earlier and we were focusing on are not very practical for small farms. That's why innovations in compact and low-cost smart mechanizations are emerging now. We have seen the PAU presentation just now, Dr. Manjit Singh made, earlier presentations by Hexagon and earlier presentations by Dr. Kale. And more than that, there are several startups who are working on developing such compact and low-cost machines for smart mechanizations. We do have mini tractors and power tillers, multi-purpose attachments for different, same power unit, we have multiple attachments which are more economical, small attachment, low-cost harvesters and threshers, battery-operated portable electric tools, and robotic machines. They are emerging as the best alternative for small farm mechanization. Next. Robotics means small farm mechanization. We have autonomous weeding robots. People are working on it. We don't have very successful models, but they are in a research and very advanced stage of development. Seeding and planting robots. We have a drone technology for mapping and spraying technology. We're trying SOPs are being developed, regulations are being developed. Robotic harvesters also being tried at different places for tomatoes, strawberry, grapes, and many other crops. And we also have to have an IoT-enabled mechanization like IoT-based irrigation systems and IoT-based other mechanization systems like tractor was shown by driverless tractor was shown by Dr. Manjit Singh now. So such innovations are going on in the country now. Next. Now emerging trends are that there are a lot of startup working on in the country on agri-technology innovations. There are many companies which I can name, and they have a lot of innovations in pipeline. I don't see any innovation is perfect and now it's ready to go to the field. But in years to come, probably these innovations will make significant change in making operational small farms in the country. Then swarm robotics. Instead of having a large robo, we can have a small number of robots in a small farm and low-cost robots working together rather than one big machine. Then AI and machine vision, for example, weed detection, fruit ripeness, this detection of these things, we can have the machine vision. Also battery-operated, solar-powered mechanization to reduce diesel dependency. So these are all different options. They are emerging as an adoption in small farm mechanization. Next. Now, key challenges is lack of training and skill and awareness of the people that Hexagon mentioned that they are skilling the people, students, incorporating the different, PAU said that they have introduced a new subject, diploma subject and also master's course. Inadequate, we don't have sufficient infrastructure with our agriculture universities as far as this area is concerned. We do have diverse systems. We need a lot of focus agroclimatic wise. Also, we need we do have institutional and policy constraints. We do not have adequate policies to promote mechanization of small farms, especially the smart small farms. Our labor availability is absolutely not there now. Cost of labor is increasing, but there are also opportunities. The opportunities are we have to reduce operation and maintenance cost. Custom hiring centers we have tried last several decades, they are working better. Large machineries also can go to small farms. Submission on agriculture mechanization has to tune to have a small farm, focus on small farm, subsidization, etc. Technological innovations on compact machinery development. I think we have seen PAU already, some models are being developed and several other startups and the universities are doing work on this. We should also strengthen the extension services and training in the universities so that it goes faster to the farmers, land users. The local manufacturing, after self-service and availability of spare parts of these new machines, robotic machines, is also an important component that needs to be done. And also we should have a supporting policy and regulatory support infrastructure. Next, these are challenges, but that can be met. Also, what needs an emphasis? Now, design for the scale and shape. We have large machinery available across the globe. We should scale down the machinery to suit the small and marginal farms. We should also have affordable models and shared ownership, maybe under farmer producer companies or farmer custom hiring centers, etc., as intermediaries. Also, sustainability aspect should not be looked after. Both environmental and economic sustainability of the new models and machinery should also be kept in mind. The integration of digital and IoT to have the optimization of uses, and it should be affordable and accessible to the small farms. Then we should also have a supporting ecosystem, for example, maintenance, skill operators, financing, market linkage, etc. And also inclusive access. It should be ensured that it is available to market marginal and small farmers. Next. To conclude, I could say that small farms is a national need now. Those farms which are automatically precision, using precision models, small machinery, without requirement of a human labor force, but some skilled labor force is required. So this is a national need today. Without that, our 86% of the small farmers will not really be supporting our food security. AI-based farming is initiated in the country already. In Maharashtra, government is the first government which has AI policy, AI agriculture policy. And at Baramati KVK, they have initiated AI-based sugarcane farming, and they are going to spread to 1 lakh farmers in the state for other crops also. There are startups in agro-robotics, several startups actually, what we have seen it no more than that. We recently have supported by Maharashtra government, Pune Agri Hackathon, organized by district collector of Pune, but it was supported by government of Maharashtra. And then I was chair of the jury, and Dr. Indramani was also a member of the jury in that hackathon. We selected about 16 innovations which are promising and ready to go to the field in next few years. I think this kind of hackathons also generate interest. The first prize in this hackathon was 20.
Arun Kumar sir, research and Dr. Syed Ismail sir, CEO, Radiant Event Solutions. Next, Dr. Manjit Singh sir, respected Dean, SAET, PAU, Ludhiana. Now I express my sincere thanks to Honorable Chairman of this session and all the speakers. After this session, we have a panel discussion. Sir, I request you. Yes, sir. Oh, sir, bolo for panel discussion, I like to call Honorable Vice Chancellor MGUEVV Durg, Professor Ravi R. Saxena sir. Next, respected Director CIFET, Dr. Ajit Verma sir. National Head Sales and Marketing, Tirth Agro, Mr. Ravi Mathur sir. And I request Dr. S.S. More sir, Head Department of Agriculture Economics, VNMKV Parbhani, act as moderator for this panel discussion.
So, good evening to all. करतात ना सर पॅनलिस्ट कोण आहे ठीक आहे
हॅलो हाँ बरं साहेब याच्यात हे आहेत ना डॉक्टर अंबिका प्रसाद साहू
yes sir
is also one of the panelists please
may I invite Dr. Sahu sir to join us for this panel discussion. So we have a distinguished panelist, Professor Ravi Saxena sir, then Ravi Mathu sir, and now Sahu sir also has joined us. So I request panelists and I request the audience to start the discussion on the theme, that is farm mechanization, sensors, IoT and robotics. Thank you sir. So we will proceed from the panelist from Ravi Saxena sir, and then we will have the remarks from Mathu sir and followed by the Sahu sir, and then we'll invite the queries from the audience, and then we will have the discussions. Thank you sir. So I request first of all Saxena sir to proceed the panel.
Good evening all. This topic of this technical 2 session was farm mechanization, sensor, IoT and robotics. It's a very recent topic and I have seen some of the good presentation from this side. Of course, there is a big challenge for small and marginal farmers for mechanization. And you will not find that the farmers are not getting even the low-cost machines for their farm operations. So it's a big challenge. So I would say that if the farmers whose income is less than 1,000 or 2,000 rupees per month, how can he afford the high cost machineries for operation? Because labor is a big problem in the throughout the country. Even in my Chhattisgarh also, I have seen that laborers are not available for 1 and 1.5 acres of the land. So I will ask these persons that how can we meet out this situation in the country? This is very, very big problem. Whatever we have seen the presentation, see, lot of machineries have been developed. Still farmers are not getting. I have surveyed the rural areas of Bastar region, Dantewada, Sukma, Bijapur. That I found that our technology is not going. So this is big challenge to us. We have developed some mobile applications also. We are also transferring the technology through Crop Doctor 2.0 application, which is AI based applications. So, but still farmers are not having the mobile internet connectivity. They are not getting the good inputs. They are not getting the original fertilizers. So we need to develop such kind of machinery, such kind of applications for the small and marginal farmers, because the number is 80% around. So this is very, very challenging job for us. We are the scientists and we should think of it. Secondly, the technologies developed by this hexagon, I have seen the hexagon presentation, how this technology will go to the marginal farmer. We need to think of it. Otherwise, this will be within the room only. So this should be very, very low cost. Even we cannot afford it. Industry cannot afford it. Our budget is not so much. So that is also seen. This very good work is going on in the PAU Ludhiana. But I know that these work based on IoT. See, IoT is most of the sensors we are purchasing from the China. I have also developed one IoT device for identification of NPK and ECPH. But still there is a challenge. The cost of the sensor is near about 50,000. I am unable to provide this sensor to the small and marginal farmer. So this is also a big challenge. If we want to have the success of this workshop, this symposium, we must think of that this sensor should come within 5,000 rupees. Then only they will adopt. अगर मैं आपसे उस तरह की बात करूं, छोटी फार्मर के पास वीडिंग का कोई इक्विपमेंट नहीं है, 1 and 1.5 फार्मर के पास फावड़ा और गैती के अलावा कुछ नहीं है. सो दिट्स वेरी वेरी इम्पॉर्टेंट कि हम वीडर, लो कास्ट वीडर दे दें उनको. सोइंग के लिए कोई मशीनरी है, उनके अगर लेबर नहीं है और अगर लेबर कास्ट अपन उसमें इन्वॉल्व कर दें तो आप पाएंगे. जैसे मेरे पास 1 एकड़ का एक ज़मीन है, मैंने लिया ही इसीलिए था कि आई वांट टू सी दैट कि किस तरह से उसमें फार्मिंग की जाए, बट देयर इज़ नो लेबर. अब इतनी घास को उखाड़ने के लिए भी, वीडिंग करने के लिए भी 300 रुपये का लेबर एक दिन में लगाते हैं, तो आपको कॉस्ट बेनिफिट रेशो निकालेंगे तो यू विल बी इन लॉस. This is actual fact I am saying, because I am making survey, I am doing the survey of each and every area. So this challenge we have to see about this. And the last sir was telling PD ki Akola, Honorable Vice Chancellor of the Akola, small farm, marginal farmers, small farms, we cannot deploy the high cost sensor in that. आप कितना भी IoT बना लें, उस IoT को जब तक उन छोटे फार्मर पे नहीं जाएगा, बड़े फार्मर पे हमको नहीं जाना है. हमने आई हैव सीन दी दिस, आपको इवन मैं बताऊं आपको कि बड़े फार्मर्स आपको पूछेंगे भी नहीं. हमने जिस दिन जाने की कोशिश की, दुर्ग में एक फार्मर हैं, 300 एकड़ का फार्म है, they are already having the machines. So in the conclusion part, I would say that we should develop the low cost machinery. We should really go to the marginal farm. Then only it will be success for us. Thank you so much.
Thank you, sir. We have well noted your points, as sir is from the statistics background. So the most and foremost problem is the adoption of the farm mechanization. And as we know that the many of the farmers are small and marginal, and one of the limitations of the adoption, the technology must be the cost-effective technology. Then it will be spread across the length and breadth of the country. That is very good, sir. The thing is that we require the machineries, but it must be the cost effective, whether it is small or large. So that is the point from your speech. And what about you have taken, that is the sensor, which must be the cost effective. That is again, we are revolving around the economics of the technology. So even though the technology is having the potential, but it must be the cost effective, then the farmers will adopt, or the stakeholder will adopt it. So thank you, sir, for your guidance. I request the next speaker, that is Ravi Mathu, sir. He is from the industry person, so I invite his comments, and then we will have, once we will finish all these comments from the speaker, then we will interact with the audience, sir. Thank you, sir.
Thank you. I would like to add one very critical point over here, is that farmer doesn't have a control on his yield. He cannot control the price of his yield. That is the biggest challenge everybody is facing in this world now. The person who is deciding his crop prices is nowhere related to the crop, or nowhere related to the field, and nowhere related to the agriculture profession also. The core purpose of this symposium will be fulfilled once we talk about how can we make the agriculture operation as economical as possible, which the speaker before me just spoken out. How can we address the bottom of the pyramid of the farmer who are really a small marginal farmer? There is a huge potential to uplift their stature so that their contribution toward the GDP can be increased in a very, very possible way. The most challenging factor is that we are also in mechanization, the machineries which we are developing, we try to make it as economical as possible, as affordable as possible. Government is also supporting in terms of a subsidy, in terms of a customizing center, in terms of a demonstration. Every possible way it is going there. But how can we make a mechanism so that the small farmer adopt that machines? Though the tractors have also came in a small horsepower, every possible equipment of a conducive environment has been created, but the challenge is still left out. I will just give you one critical example. When my organization launched the sugarcane harvester, for the sugarcane harvester we have to first have a pattern sowing, then only the machine will work. We took around 7 to 8 years, and thanks to the universities and the Institute of Sugarcane Research who had helped us a lot to make the mentality change, to make the mental blocks eroded in the farmer community. That was the biggest thing that institutes have done. Thanks to all the universities of Maharashtra, particularly Parbhani, where a lot of education has been done to the farmer community for bringing this kind of a mechanization in the sugarcane industry. It was actually I can say a turning block where the mechanization has been adopted. And after that, I can say a kranti has been started, where the sugar mills are also initiating that how can they yield the crop of that particular village or at that particular targeted segment. They are now encouraging farmers for the intercultivation operations. They are encouraging farmers for use of fertilizer. They are encouraging farmers toward the breed sowing also. There are a lot of activities has been done. The basic challenge still lies there, how can we make agriculture economical so that this yield solution can be increased. Because two bigger challenges there: to feed the nation, where the continuous population is increasing, almost we are now crossed 1.4 some billion, and the land holding becomes smaller and smaller and smaller and smaller. That is also a bigger challenge. So there the government is also supporting. I thanks everybody on this forum. We are here for making a symposium successful by bringing this core statement, how can we increase out this and address out this marginal segment over there. Thank you.
Thank you, sir. Again, the core of the discussion is about the economics only. The thing is that we are developing, or we are here to address the real farming situation, especially the labor problem we are addressing. And as we know that the machines which we have developed, still it is not cost effective, especially when we are talking about the small and marginal farmers. They cannot adopt it. And one of the problem you have given to us to have the research on why small and marginal farmers are not adopting the mechanization, we will resolve it. But the thing is that, sir, the example which you have set, no, especially for sugarcane, the harvester, because of the industry support, no, now still it was popularized. But when we are talking about the one crop which is specially grown by the small and marginal farmer, that is Rabi Swargam, still it needs the mechanization. And there are two lacunas in that crop. The mechanization is not up to that level, and if even it is there, whether it will be adopted by that farmers, because they are resource poor farmers. So the thing is that when we are talking about the mechanization for sugarcane, because of the industries is supported, so it was there in the field. But we have to see when no one is there to support the farmers, how mechanization can go in the field. So that is the real problem that we have to address it. Thank you for elaborating your views, sir. Thank you. Now I invite the next eminent speaker, Dr. Sahu, sir, to share his thoughts on this issue, and then we will interact with the audience. Thank you, sir.
Thank you, sir. The most respected vice chancellors and deans and directors from all over the country, thank you giving me the opportunity. So this is a very good theme, farm mechanization, sensors, IoT and agri-robotics. So the presentations were very nice. I listed some of the points. Actually this is meant for the small and marginal farmers. If you can give the example, I am from Odisha. So the small and marginal farmers is around 91 to 92%. And out of 61 lakh, around 16 lakh hectare, 47% is lying under highland, around 28% medium land and 25% in lowland. Again in highland, it is very fragmented and these are located at the hilly areas. So the land holdings are very short and also the geometry is not good. So there you cannot go for this mechanism robotics. So it will the AI and sensor based robotics that will perform better when the area is large. But in small it is not possible. Tractors cannot also be used. Only the power tillers can be used. But we have to think of the multitasking like spraying, then digit detection like this. So how can it be best fitted in the power tillers? That can also be think of. That we should think of. Then this low cost sensors. One of my PG students, she was doing on the soil moisture sensor for automation of drip irrigation. It was low cost, but there is a need of say like research, multidisciplinary research hub, where the engineers, agronomists, agriculture scientists, then computer science based and engineers should work together to develop these small low cost sensors which will be used in the robotics. Another is so since this the end users are the farmers, so they should the technologies should be disseminated to them. So before that, now this agriculture, without this agri-robotics, we cannot think of this future agriculture. It is a must. That's why the say in SAUs the faculties are to be trained. That is another important point. The instrumentation facilities that must be upgraded and developed, and the technician and staffs those are present, they should also be trained, and they will transmit to the next stakeholders. So there is a need of this training to all. And since the marginal farmers are there in the rural areas, like Sir has told, the interconnectivity of the internet facility, that is a must. Without that, we cannot remotely operate these robotic machineries. So that is also important. And another is since the major contributors are the women in the agriculture, and today morning, as the Chief Minister Madam has said, that we should think of this gender consideration, so they should also be trained. And for them also, the suitable technology and design should be there, so that they can also use the advanced technologies. So these are my concerns, so that should be taken care of. Thank you, sir.
Thank you, sir. Really enlightening. The two takeaways from your discussion, that there will be no one technology for all the solutions, because it varies from the state to state and region to region, agroclimatic regions also. So we cannot have the one technological solutions for all the problems. So it must be the region specific, or we have to modify as per the site requirement is there. The second and which foremost important is the role of woman in agriculture, especially when she has to adopt the mechanization. So whatever the machines, whether it is small or big, we have developed for to address the problems only, but it must be the gender neutral. So it must be suitable for men as well as it must be suitable for the women. And if not, we have addressed this issue, we have to address the issue in detail, sir. So thank you for sharing your views on this. Now I would like to have interact all these eminent speakers. I request some specific questions or anything which you would like to discuss with this panelist. Then it will be great. Thank you. Yeah. Yes, sir. Please, someone hand over one mic to.
Hello.
Hi, sir. Myself Arun, representing Hexagon, iValue and the group. So thank you for that feedback, which you all three eminently put out, that mechanization, robotics.
One of my requests is that one person is sitting here who cannot understand the English.
ठीक है सर.
ठीक है? He is very much this robotics person, if you will find in the last.
ठीक है.
और उनका रोबोट अभी शायद आप लोगों के यहाँ पे परभनी में है भी, तो मैं चाहता हूँ कि आप हिंदी में बोलें उनके लिए.
डेफिनेटली. थैंक यू. तो सर हमारा iValue and ग्रुप जो ये सिट्सा प्रोग्राम कर रही है, ये हमारा पहली स्टेप है, बिकॉज हर कंपनी मिलजुल के प्रगति कर सकते हैं. तो जैसे आपने बताया, लो कॉस्ट, मेकिंग इट मोर इफेक्टिव. Okay. So making it more effective and taking it to the end user, that is our farmers ultimately. तो यहाँ पे पहला आता है यूनिवर्सिटी स्टूडेंट्स जो we have to uplift. मैं थोड़ा मिक्स करता हूँ because तो we have to uplift student, faculty, scientist community. तो इसलिए हमारा ये प्रयास है कि मेजर फोकस जो है सारे लैब्स पे दिए है, एंड रिवर्स इंजीनियरिंग जो चाइना में जितना प्रगति हुआ है, एंड मे बी शक्तिमान नोज इट बेटर कि कैसे होता है अंदर सिस्टम पे. तो पहले है ये टूल्स एंड टेक्नोलॉजी जो है उसका एक्सेस देना चाहिए. तो ये हमारा सारे 40 कंपनियां जो बेस्ट ऑफ बेस्ट है वर्ल्ड में, जो मे बी बहुत कंपनीज यूज़ करते हैं एट द बैक एंड. तो वही टूल्स एंड टेक्नोलॉजी कमर्शियलाइज्ड, दे आर नॉट फॉर रिसर्च, दे आर नॉट फॉर एजुकेशन, बट दे आर द सेम कमर्शियल टूल्स जो है हमारे सेंटर में सुविधा प्रोवाइड किया जाता है. So they can use that and start building equipments which is very specific to that state, that region, that local district. So that is one step that we have taken from the whole group. कैसे हम student और faculty मिलजुल के इसको mechanize कर सकते हैं. Number one. अगर हम robotics का बात करेंगे या mechanization का बात करेंगे, every component, मतलब एक robot बना में maybe more than 400 to 500 components लगते हैं. कितना हम मेक इन इंडिया कर रहे हैं? क्या हर पार्ट कर रहे हैं कि पूरा कर रहे हैं? वी आर सिस्टम इंटीग्रेशन में, हाँ हम बहुत अच्छे हैं, बट फंडामेंटली एक सेंसर डेवलप कर सकते हैं,
एक कनेक्टराइजेशन डेवलप कर सकते हैं, एक हार्नेस डेवलप कर सकते हैं। तो ये कोर एरिया है जो मेजर पेन पॉइंट्स है जो हमारा सिस्टम में हम एड्रेस कर रहे हैं कि आप सीखो कि ऐसे हर पार्ट ये सब पार्ट कैसे बनाया जाता है और पूरा सब पार्ट इंटीग्रेट करने के बाद एक कैसे एप्लीकेशन बनता है। तो जब तक हम सारे पार्ट्स मेक इन इंडिया नहीं बना पाएंगे, एटलीस्ट इफ नॉट 100%, एक प्रयास है एटलीस्ट 50% पहले, फिर 60%, तो एक एक करके मेक इन इंडिया करके उसका कॉस्ट ऑप्टिमाइज करके तभी इट इज़ पॉसिबल टू टेक इट टू फार्मर्स। तो हमारे पास एक्चुअली बहुत अच्छे से हम भी सीखे कि एक फ्लाई ट्रैप आता है, सिंपल सोलर का फ्लाई ट्रैप आता है। फार्मर्स का हमेशा कंप्लेन है बैटरी चला गया, बैटरी ड्यू टू वाटर ह्यूमिडिटी के लिए वो कनेक्टराइजेशन रस्ट पकड़ लिया, बैटरी चेंज हो गया। तो हमारा एंटरप्रेन्योर ने बहुत अच्छा सोल्यूशन दिया कि 10 साल विदाउट हैजल फ्री चलता है। ही चेंज द कॉन्सेप्ट। तो ऐसा जो स्टूडेंट्स को अगर फैसिलिटी दिया जाता है तो दे हैव लॉट इन्वेंशन कैपेबिलिटी कि वो सोल्यूशन खुद लेके आते हैं। तो हमारा ग्रुप से हमारा सिर्फ इतना ही मकसद है कि फैसिलिटी दो, प्रॉब्लम स्टेटमेंट बोलते हैं पीडीडी, क्योंकि ये पीडीडी हम फ्रैंकली बताते हैं ये हमारा कस्टमर कंप्लेंट्स है या कस्टमर्स जो हमारे ऊपर चिल्लाते हैं वही है पीडीडी, तो इसको सॉल्व करो। तो बिल्कुल वो प्रॉब्लम स्टेटमेंट हम स्टूडेंट्स को देते हैं और वो उस पर वर्क करके एंड प्रॉबली सोल्यूशन निकल के आते हैं। दैट इज वन ऑफ एन एस्पेक्ट जो आई वांटेड टू ब्रिंग इट टू द पैनल। एंड सो नेक्स्ट थिंग इज द रोबोटिक्स एंड ऑटोमेशन। अभी बच्चे दे आर माइग्रेटिंग, वी ऑल नो गोइंग टू अलग फील्ड्स जॉब्स, तो उनको दिखा सकते हैं क्या कितना जॉब्स अवेलेबल है ओनली इन इंडिया, क्या सैलरी पैकेज मिलता है, क्या उनको क्या स्किल चाहिए टू एक्सेस दैट काइंड ऑफ अ पैकेज और दैट काइंड ऑफ अ स्किल। तो ये हमारा पोर्टल से वी आर ट्राइंग टू गिव दैट रियलिस्टिक डेटा सेइंग दैट अगर ये आप एक्सेल करेंगे तो ये कंपनी आपको इंटरव्यू करेंगे, आप यदि ये इंटरव्यू पास करेंगे तो आपको ये जॉब मिलेगा ऑन अ पर्टिकुलर लोकेशन और अ पर्टिकुलर कंपनी। सो दैट वे वी आर ट्राइंग टू एंगेज एंड अट्रैक्ट स्टूडेंट्स। एंड हमारा पायलट में हम एंटिसिपेट नहीं किए थे, हमने सोचा कि 400 to 500 ट्रेन करेंगे, बट फॉर आवर सरप्राइज देयर इज मोर देन 1700 स्टूडेंट्स जो ट्रेनिंग लिए एंड बहुत सारे केस स्टडीज बन रहे। तो मे बी दिस इज द वे वी हैव टू गो स्टेप बाय स्टेप स्लोली। फर्स्ट फैसिलिटेट, उनको फैसिलिटी दिए जाए कि एक्चुअल वर्ल्ड में क्या होता है एंड हमारे यूनिवर्सिटी में क्या होता है, मोर और लेस सेम रहना चाहिए।
सर,
so that's the opinion that I have, and thank you so much for that.
Thank you. The good point is that sir has shared the access. So I think the industry academic collaborations, by this if any industries come forward to showcase their state of art technologies, that will be the best one. That is there. Apart from all these things, they are well noted. Anyone? Yeah. You want to add? Yeah.
Right from the day of as a student we had developed it, and unfortunately still that cultivator is still in the field. So that is actually I can say almost 30 years now after getting out of the institute, still cultivator is plying. That means the progress is very, very low. That is there. It is made affordable now. It is now many of the industries are intervened and make a very, very economical scale of affordability there. But still the migration from a prosperity of a cultivator to another product, that is rotavator, still a big league is there to cover up. So my request to the institute is that how can we as an industry also, we are making our feet forward to collaborate with the institute and the universities to educate and nurture the upbringing of the students who are here, who is going to be a change leader now to the world. तो we are always there. हम आप सबसे रिक्वेस्ट करते हैं, जितने मेरे आज यूनिवर्सिटी के डीन्स वाइस चांसलर्स आए हुए हैं कि हम एक कदम आगे बढ़ा करके आपके साथ कोलैबोरेट करते हैं और जितने भी बच्चे हैं यहाँ पर उन सबको एजुकेट करके उनको आगे फॉरवर्ड फुट पे कैसे लाना है वो हम लेके आएंगे उनको, बिकॉज आज सबसे बड़ा एक चैलेंज है जो आई थिंक वन ऑफ द
minutes with the dynamic leadership of Dr. Honorable Vice Chancellor Manish sir. It will be great if
a request from you. It is the reverse. We have a world-class technical training center in our plant. So I would request a university and institute great facility. I cannot pep up myself, but once somebody visit there, he will really feel a delight, a wow factor over there.
So, yeah, thank you, sir. That can be done under internship program.
Yes, sir.
That we will see.
Thanks.
Yeah. Anyone? Any? Yeah.
आदरणीय सक्सेना सर जैसे छत्तीसगढ़ से हैं, वो बोल रहे थे कि हमारे जो किसान हैं उनके पास लगभग 1 एकड़ 2 एकड़ ज़मीन कैसे यूज कर सकता है। तो हम देख रहे थे पिछले गवर्नमेंट में हमने देखा कि एक गोठान स्कीम था, कम्युनिटी स्कीम था, एक ही जगह सब चीज़ ला के उसमें डेयरी फार्मिंग को कैसे अच्छा किया जाए, अपने एनिमल को फीडिंग कैसे किया जाए, इस टाइप का एक स्कीम था। तो मेरा ये भी मानना है कि जैसे छत्तीसगढ़ में जो भी हमारे फार्मर 1-2 एकड़ ज़मीन है, अगर एक गांव को देखा जाए तो एक गांव में लगभग 300-400 एकड़ ज़मीन हो जाता है। और अगर इसको देखा जाए, अगर एक कम्युनिटी में लेके अगर उसको मैकेनाइज करें तो ये डेफिनेटली एक बहुत अच्छा प्रयास हो सकता है। हम देखते हैं कि गाँव में कोई कहीं से अपना ट्रैक्टर, हार्वेस्टर या ऐसा कई चीज़ आता है, उसको हायर करके पूरा गांव यूज करता है। तो मेरा मानना यह है कि कम्युनिटी बेस्ड ऑटोमेशन के ऊपर भी हम लोगों को सोचना चाहिए कि एक किसान वो पूरा मशीन तो नहीं खरीद सकता, लेकिन वो गांव के लिए खरीद सकता है। दूसरा एक चीज़ और मैं देखा हूँ कि पूरा पैन इंडिया में देखा, छत्तीसगढ़ में भी है, जैसे अग्रवाल सर बोल रहे थे कि हमारे स्टूडेंट को हम फॉरेन भेजते हैं तो उसमें मोटिवेशन इतना ज़्यादा हो जाता है, फिर लौट के आता है तो बहुत अच्छा करता है। तो हम भी देखते हैं कि हमारे फार्मर को एक्सपोजर विजिट में भेजते हैं, अगर अपने स्टेट से बाहर भी भेजते हैं या अपने कंट्री से भी बाहर भेजें को देखेंगे 1 एकड़ में वो कई मल्टी क्रॉपिंग ले लेगा, इंटीग्रेटेड फार्मिंग करने की आइडिया भी ऐसे आ जाएगा। तो मोटिवेट करने की भी ज़रूरत है। ये दो चीज़ को भी देखने की ज़रूरत है। थैंक यू।
सर इसमें जो आपका एक पॉइंट है ना, सर आपके ही पॉइंट को एड्रेस कर रहा हूँ मैं। जो कम्युनिटी फार्मिंग में अगर देखेंगे, जो उसको अगर हम देखेंगे तो स्ट्रक्चर्ड में गवर्नमेंट ऑफ इंडिया ने कस्टम हायरिंग सेंटर के नाम से चलाया है प्रोजेक्ट। उसमें जो सबसे बड़ी दिक्कत आती है कि हु विल बी द कस्टोडियन ऑफ द इम्प्लीमेंट, उसकी राख रखाव कौन देखने वाला है। अगर वो राख रखाव देखने वाला एक प्रिंसिपल आ जाएगा ना, तभी वो प्रोजेक्ट सक्सेसफुल चलता है वहाँ पे। नहीं तो उसमें सबसे बड़ी दिक्कत आती है मेंटेनेंस की। मैंने यूज़ किया और थ्रो कर दिया, फिर जिसको लेके जाना है वो बेचारा फिर उसको नए स्केल से सर्विस कराएगा और फिर लेके जाएगा, तब उसका पूरा इंटरेस्ट ही खत्म हो जाएगा वहाँ पर। तो वो एक बहुत बड़ा चैलेंज है, उसको हम लोग कैसे दूर करेंगे वो हम लोग भी खुद स्ट्रगल कर रहे हैं उसके लिए। हम लोगों ने भी बहुत सारी जगह पर बहुत से अपने इम्प्लीमेंट डोनेट किए हुए हैं, बट उनकी सर्विसेबिलिटी के टाइम पे जब उनको प्रैक्टिकल यूसेज चाहिए तब वो प्रोडक्ट जो है चलने लायक ही नहीं रहता है, क्योंकि उसने अपना यूज़ करके उसको डिस्पोज कर दिया। तो वो सर एक बहुत बड़ा चैलेंज है, वो मैं चाहता हूँ उस पर आज ये सिम्पोजियम में एक सॉल्यूशन भी निकल के आए कि हम लोग कैसे लेके आने वाले हैं उस लेवल पे।
Right, sir. One of the way might be in Maharashtra, customer hiring center nowadays it is linked to the FPOs, so that might be one of the solution. But we can have the discussion at length on this topic at some time. But in Maharashtra, many of the FPOs, they are running their own customer hiring center. So the problem of maintenance and all these things, they are taking care of, and it is not of only that they are sharing to their members, but they are also sharing these facilities to the non-members also. So that model is working in Maharashtra.
One very structured model is there in Karnataka, Dharmsthala.
Yeah.
That is also doing it. But they are very big organization, very mature now. Sir is talking about a small farmers where this kind of a facility is not available. So there we will create that kind of a community. वहाँ पर हमें ये ऐसा एक autonomous mode बनाना पड़ेगा ताकि आगे facility उनको sustain कर पाएं हम लोग. That is my request. Yes sir.
Yes. Yes.
At panchayat level it will be good one. Yes.
Yes sir.
इसमें सर एक ऐसा मेरा कहना था कि हमारा एक निकरा विलेज में हमने जब डालन में था मैं, तो 3-4 गांव में हमने एक कस्टम हायरिंग सेंटर उसको इस्टेब्लिश किया था, और जो भी गांव के फार्मर है वो उसको यूज़ करते थे पूरे। तो वो भी उसका उतना प्रॉब्लम नहीं, लेकिन वो अवेलेबल होना बहुत ज़रूरी है। आपका प्रॉब्लम सही कि वो संभालेगा कौन, उसको देखेगा कौन, उसका रख रखाव कौन करेगा, ये तो प्रॉब्लम नहीं है। लेकिन अगर कुछ गांव के लोग अच्छे हैं तो वो कर सकते हैं, हमने किया है निकरा विलेजेस में। यस, थैंक यू।
Especially sir is talking about Chhatrapati Sambhajinagar. Under that KVK scheme, it was successfully implemented. Yeah.
उसका सर एक SOP अगर आप शेयर करते हैं हम इंडस्ट्रीज के साथ में, तो आई थिंक वी विल टेक इट फॉरवर्ड फॉर एंड रेप्लिकेटिंग दैट काइंड ऑफ अ सक्सेस।
उसमें निकरा में भी है, हमारा जो पोखरा प्रोजेक्ट है ना उसमें भी है, बहुत सारे विलेज में ये कस्टम हायरिंग सेंटर इस्टेब्लिश किया है, और एपीओ के पास भी है, ये बहुत सारा है। यस, विल शेयर दी एसओपी।
श्योर, वो सीखने जैसी बात है उसमें, अच्छी चीज़ है वो।
I think if there is no question, shall we stop here, sir? Yeah. Thank you. Thank you for interacting. Thank you.
I am here to propose vote of thanks. I express my sincere thanks to all panelists for their precise and specific comments leading to the farm mechanization for small and marginal farmers. Also, I equally thankful to all dignitaries of this group for their active involvement and interaction. Also, thanks to Dr. S.S. More sir, act as moderator for this session. And last but not least, I also thanks one and all who directly or indirectly involved in making this session successful. With kind permission of the chair and panelists, we will declare session is over. And one announcement is there. I request all the dignitaries to join the culture program at Auditorium Hall of College of Agriculture, VNMKV, Parbhani, immediately after the session. Thank you one and all.